Ooh, that's beautiful. We have more moons than I thought.
Yes. I wish we had that many moons. That would be awesome to look at. Of course, full moon period would we wouldn't need street lights. So.
Yeah.
Hello, Kareem. Good to see you.
Hey, David. Hi, everyone.
Hi.
Hello.
Hi, Samantha.
Hello. Nice to meet you all. Except for Kareem.
Yeah, it's never nice to meet me. I understand.
He ropes me into so much stuff.
I don't do anything of the sort. I just give you ideas. Whether you choose to go with them or not, that's up to you.
I can't say no to good ideas, though.
I can tell you, lots of people I email never reply, but you just reply, and so then you're stuck.
I'm banking favors for the future.
David, how's everything in Arizona?
Oh, everything's doing well, as I was telling David and Scotty. Wendy is doing much, much better.
Excellent. That's really good to hear.
And how are you doing, Kareem?
I'm recovering. I've got not 100% of energy back, but most of it. Trying to get used to this clean-shaven-ish guy in front of me. I still do a double take half the time. So the stubble helps, but it's very weird.
Wendy is getting used to her buzz cut.
Yeah, it's when we have to do these changes, it doesn't feel like it's in our control, but we can make the best of them. My wife loves the clean shaven look, so she's actually upset that I'm going with stubble. She's waiting for me to get rid of it. So I said, for Mother's Day, it'll be gone.
Yeah, that's Sunday. Yeah.
My partner had to shave to wear masks at work at COVID. I was like, nope, this is not working for me. Grow the beard back. He had a goatee. I was like, nope. He looked like his brother. I didn't like it.
What? Wendy also likes clean shaven. Hello, Carroll.
Carroll, you're muted.
That's better, I guess.
Cari can hear you.
Hi, David Eicher.
Hello, how are you?
How's it going? Hi, Karim.
And Bob is here.
Hi, Carroll.
How's it going?
Good. Oh, it's been amazing learning from Bob the last few GSPs. It's been incredible.
Okay, who is it that's saying that?
It's Kareem from Montreal, from way up north.
Okay, hi, Kareem.
Hey, Bob.
And,
I haven't been on live, but I've been watching you from afar. I took a few weeks off.
Okay. Well, this is all pretty new for me. I think this is my third time on, so.
I came on once or twice and then just stayed. So I hope you're just staying now because it's been fun.
Well,
Right. Yeah, I hope so too.
If you do this more than a dozen times, Scotty will never let you go again.
Join the mafia. Yes.
Thanks for the warning.
Mm-hmm.
No, Samantha, you have to do this a dozen or so times.
Are you trying to take all my evenings away from me?
I'll talk to Phil. We'll write it into your contract.
I already work like 3 to 4 days a week, in the evening a week.
I'm glad you specified that because 3 to 4 days a week was not sounding too impressive.
No. I meant in the evening. One of them with the telescope. I mean, we're all astronomers, but I have high school students up till 1 a.m. in the summer. So.
Exactly. It's a remote telescope. So it's a remote telescope in a different time zone by 3 hours. So
yeah, it's in California and I'm in the Eastern time zone. So
and see,
it's fun though.
Look, right there, you've got a topic for your next visit. That's how it works.
We'll talk later, Kareem.
You brought it up, not me.
I'm losing my voice from this weekend. I worked all weekend too, so.
And then what you'll find is pretty soon Carroll will rope you into being part of the Astronomical League as well, and then your weekends are gone.
That's right. We're always looking for good people. What a nice invitation.
Oh, I'm not a good person. Yeah, Kareem can verify that. Nah.
I will say,
like
despite my best efforts, she has yet to cry when I give her work to do. So.
No, you haven't made me. Oh wait, did you? You haven't made me cry yet. You tried. You tried to make me cry. In the new year, you're going to be the first one to make me cry in the new year. Didn't work.
Not happening.
You're all good.
Not happening. And Maxi, I see he's here. Did anybody see his pictures from the eclipse this weekend? It was great.
Yeah, I was at the show and people were. I didn't realize there was an eclipse down south in the south hemisphere. And then I know I'm terrible. I've been so focused on what's happening up north.
If you ask, Maxi would become Canada South for us.
Want to become RASC Canada South?
We could have a Canadian embassy in Maxi's backyard.
Telescope embassy.
Do you hear me?
We hear you.
How are you guys?
Good.
Good.
Great. Good to see you.
Good to see you too, Karim, and everyone.
We see everyone except Scott. This is the only problem with this setup is we miss seeing Scott half the time.
Pay no attention to the man behind the curtain.
That's right. That's right.
I'm picturing the old Wizard of Oz musical where you like lift over the curtain and there's a little guy sitting there controlling all the knobs.
That's right. The all great and powerful Oz. Yes.
I'm going to change that in my address book. That's from now on. Carol, for the rest of the Astronomical League Live, shall we introduce Scott that way? The great and powerful Oz?
I think that would be wonderful. Let's test it out in about a week from now.
Is that Norm?
Yep, Norm Hughes is with us.
Yay!
Yep. It's great.
But now there's nobody competing with Tarek to be the first one with their name up when we go to break.
Yeah. Well, it's time to get started, folks. So here we go.
On October 20th, 2021, dozens of astronomers gathered near Las Vegas. They pointed their telescopes at the sky and waited for the moment that the light from a faraway star blinked out. It was an event so minuscule, it would have been easy to miss. Yet the data gathered by scientists from those few seconds helped contribute to the success of NASA's Lucy mission. As the astronomers observed the star, it appeared to blink out as asteroid Euripides passed in front of it. Euripides is one of 7 Trojan asteroids Lucy will visit over the next 12 years. The Trojans are clustered in 2 swarms that orbit the Sun at the same distance as Jupiter, though they're as far away from Jupiter as they are from the Sun. These asteroids are remnants of the early solar system, and by analyzing them up close, scientists can hone the theory of how the planets formed and ended up in their current locations. As Euripides eclipsed the star, a phenomenon scientists call an occultation took place, whereby a shadow the size of the asteroid passed over the region. The best known example of an occultation is a solar eclipse, which occurs when the moon passes between the Sun and Earth, blocking the Sun from our view. Leading up to the occultation, astronomers predict the asteroid's shadow's path across Earth and set up dozens of telescopes along a line that's perpendicular to that path. Spread out under the asteroid's shadow, they count the seconds the starlight blinks out as the asteroid passes in front. Using the asteroid's known velocity, it is possible to calculate its width. By observing multiple occultations of the same asteroid, scientists can catch different sides of the asteroid and combine their 2-dimensional silhouette projections into a 3-dimensional shape model. Observing an occultation is one of the most reliable tools scientists have to gather information about Lucy's target asteroids and prepare for flybys of each of the mission's targets. The team will continue to observe occultations until Lucy's last flyby of Patroclus in 2033.
Hello, everyone. This is Scott Roberts with Explore Scientific and the Explorer Alliance, and this is number 92 of the Global Star Party, and I'm very pleased that you're here to watch this. I have with me tonight some of the great astronomers from around the world, and we are going to start our night tonight, of course, with David Levy, moving on to David Eicher, Carroll Orge from the president of the Astronomical League is with us, and many more are with us as well. And so I hope you really enjoy tonight's presentation. David Levy starts off all of our global star parties. He characterizes each one based on a theme that we have going, and but he always ends it very eloquently with some poetry or a reading that's always inspiring. And so, David, I'm going to turn this over to you, but thank you for coming on to the 92nd Global Star Party. We're getting close to 100.
Yes, we are, Scott, and thank you. It's good to be here. When I first started in astronomy in Montreal, Isabel K. Williamson, this was long before the days of Kareem, Isabel K. Williamson suggested that I start the Lunar Training Program. And that program involved looking at 300 craters of the moon with a telescope, identifying them and creating them into my own map. And I did that. I finished it by 1964. But as I was doing it, one of the craters that I noticed was one named Rabbi Levi. And that was kind of interested me, but it wasn't until more recently that I found out more about Gersonides, or Rabbi Levi ben Gerson, who this crater is named for. And it's actually very difficult to find examples of his writing, but I have found some. And they really are. He really presents a lot that is cause for thinking and for reflection. One of the things he said is about peace, and I think those of us who are witnessing the fighting in Ukraine right now, the war in Ukraine, will agree with this. A peace that comes from fear and not from the heart is the opposite of peace. And the other one is something that comes right out of the 19th Psalm about day after day yieldeth knowledge, night unto night yieldeth wisdom. And Gersonides writes, do not lose sight of wisdom and understanding, but preserve them always. And on that note, I give it back to you, Scott. Thank you.
Thank you very much, David. Thank you. Yes, we are, of course, all watching what's going on in the Ukraine every day, and our prayers go out to the innocent people out there that are being affected. So, thank you for bringing that to our attention, David. So we're now going to move to Carroll Iorg. Carroll is the president of the world's largest federation of astronomy clubs, the Astronomical League. They have over 300 member organizations. They are very much friends with other federations of clubs, including the Royal Astronomical Society of Canada. They are getting ready to have their next Astronomical League conference, which will be an in-person conference. They've asked me to go along to help broadcast it to those of you who cannot make it, but it is a tremendous event. And the in-person aspect of these events are very important because you actually get to meet people and make friends with people that you might not otherwise get a chance to do. And I would say that those friendships are something that all of us that are in the amateur astronomical community hold near and dear. I can't tell you how much I value all the friends that I've made, many of which are appearing here tonight on the 92nd Global Star Party. Carroll Iorg is no exception, and so Carroll, I'm gonna put the spotlight on you. Thanks for coming on to the 92nd Global Star Party.
Thank you, Scott, for that wonderful introduction. Some of it might be true. I don't know. Anyway,
It's all true.
yeah. But yes, after 2 years, actually, we're finally going to be able to meet in person in Albuquerque. They have been very patient, and they've hung with us for 3 years in a row. So this one's going to work. And David, thank you for those wonderful words you gave us to keep it all in perspective as we see the good in this world, not just what's going on in the outer. So thank you for sharing that.
Thanks.
Okay, let me share my screen, and we need to look at the questions. Let me move the screen a little bit over here. Just a second. Okay. My apologies.
Carroll, you have, close that window, yeah.
Let's see. Okay.
That'll work just like that, Carroll, if you'd like.
Okay, let me go up here and see if we can. All right. Okay, we like to begin each meeting with the precautions. If we have door prizes later on that are awarded, we want to make sure that the proper precautions are used. Many of our amateur astronomers don't need these notifications, but for anyone new in the hobby, we want to make sure they're not looking at the sun through one of the optics and risk the having some eye damage. So we always like to put that up there. Okay, let's get into the answers from the last star party we had on April 19th. And some of these were dated for that specific night. Question number one for that event, they were talking about the next day after that event, 2 weeks ago. Tomorrow morning, 45 minutes before sunrise, what four bright planets can be found spread apart in a line like jewels on a celestial necklace in order from east to southeastern horizon?
Carroll?
Yes.
Carol, yeah, you're not focused on the presentation window.
Oh,
So
sorry
you
about
can't
that.
see the, so you might want to unshare and then go back and share with your presentation window.
Oh, here we go. Yeah. All right. Yeah, that's where I need to be. You can see it now?
Still not, no,
Still not there. Okay. Sorry about that.
it's all right. Yeah, I think you're focused just on the
Yeah, we'll
PowerPoint.
get there. I've been on 3 different
application
computers the last 3 weeks, so
Yes.
I'm an amateur at this also. Let's see here. Okay, and
It might be easier if I unshare you or have you unshare and then go back and share. So let's
Okay.
do that.
all right,
All right?
got that. All right.
Yep.
Okay. And can you see now?
Let's see. Your computer's working.
You see anything just yet?
We see it looks like question 3.
All right. Okay. We're in the neighborhood. Sorry about that. Okay. And the answer to that first one, tomorrow night, 45 minutes before sunrise, what 4 bright planets can be found spread apart in a line like jewels on a celestial necklace in order from the east to southeastern horizon? The answer to that one was C, which was Jupiter, which was Venus and Jupiter. Number 2 question. Let's see. Well, the answer to that first one was C, which was Jupiter, Venus, Uranus. No, I'm sorry. It was B, Jupiter, Venus, Mars, and Saturn. Now we go to number 2. A major planetary conjunction, one that the public will be definitely interested in knowing about, occurs on the final morning of April. It can be seen about 40 minutes in the southeast before sunrise. What 2 planets are involved? That was Venus and Jupiter. Then the third one from that last one, the location of the galactic North Pole on the celestial dome lies just east of what well-known star cluster? The answer was B, Coma Berenices. And the correct answers from that one were Cameron Gillis, John Williams, Andrew Corkill, Josh Kovac, Andrew Corkill, let me get the other 2. And then the answers for April for the grand prize winners was Josh Kovac and Michael Overraker. So now let's get to the questions for tonight, May 3rd.
For this part, I think what I'm going to do is stop the sharing because you're still on your same slide. So and it'll work out just fine if you just read the questions. So
Okay, that's what I'm going to do. Yeah, and my wife has promised me a new computer before we have another one.
Okay.
So we're going to get this solved.
No problem.
Yeah. Anyway, okay, all right. So let me get to the. Okay, question number 1. The James Webb Space Telescope's mid-infrared instrument, that's MIRI, finally reached the super cold temperature needed to operate as designed. The questions: what are the approximate temperatures in Kelvin, Fahrenheit, and Celsius? What are the approximate temperatures in Kelvin, Fahrenheit, and Celsius when they got the temperatures cold enough to operate the instruments? Send the answers to secretary@astroleague.org. That's number 1. Question number 2. Who is Jessica Watkins? Who is Jessica Watkins? And again, send the answers to secretary@astroleague.org. Question number 3. How many moons does the planet Mars have? How many moons does the planet Mars have? And again, send those to secretary@astroleague.org. And finally, our friend from Canada was talking about some things we probably need to do in a couple of weeks at the Astronomical live event. The featured speaker for that will be Dr. Jessica Novell, whose specialty and the topic of her talk will be volcanism in the solar system, and that's defined as the eruption of water, ice, and dissolved volatiles onto a body's surface. Pluto's moon, Charon, shows evidence of that resurfacing, but the discrepancies between the estimated surface age determined from crater counts and the estimated time of that start raise questions about Charon's history. I'll be on there along with Chuck Allen and Terry Mann from the League, as well as Scott Roberts and David Levy, 2 regulars, of course, on this. And finally, this summer, talking about Alcon, the dates for that are July 28th through 30th, 2022. And to get registration information, go to the League website at astroleague.org, and all the information is there. Registrations are coming in very nicely, and we'd love to have you in person. Like we said earlier, this is the first time in 3 years we've been together for one of our national conventions. We're looking forward immensely. And as Scott was saying earlier, 2 years from now, we'll be teaming up with our neighbors to the north in Canada for the first ever joint convention with our 2 groups. Next year, we'll be meeting in Baton Rouge, Louisiana. So with that, I'll turn it back to you, Scott. Thank you very much. And sorry for the interruptions.
Oh, no problem. So that would be a meeting jointly with the Royal Astronomical Society of Canada, correct?
That's correct. And I'm talking off the top of my head, but I believe we're doing it right before Canada Day, the end of June in 2024.
Right before Canada Day, right after that awesome totality that we'll all hopefully get to see with beautiful clear weather throughout the path.
That's right.
Kareem has guaranteed the total eclipse will be visible wherever we go. So everything's good.
Excellent. Excellent. Thank you, Carol. Thanks very much. And if you don't already belong to the Astronomical League, we do encourage you to join. You can join as a member at large. And I have posted the League website, but it is astroleague.org. So thanks again, Carol.
Yeah, we're 22,000 strong, and we're always looking for other good members. So
yes,
love to have you.
Thank you so much.
Sure.
Okay, so that was wonderful. And we do appreciate the Astronomical League for coming on to Global Star Party each week to share their questions and to challenge our viewers. part of the door prize assortment is going to be a couple of books. We're going to talk about the author of these books here a little bit later, which is Michael Carroll. But coming up next is, I talked about friends that you make at astronomy conventions and stuff like that, that actually go on to be real friends. And certainly David Eicher is one of those to me, but he's a friend to many, many thousands of amateur astronomers and people also interested in history. This guy has so many facets to him that his friend list, his contact list at least, in his phone must be almost bursting the memory banks of that smartphone. So, but I'm very pleased and honored to consider, to be a friend of David Eicher, and we hope that you attend some of the events where he's there live. One of those is going to be Starmus, and David Eicher will talk about that in just a few minutes. But let's bring him on to talk about his latest insights into minerals of this planet Earth. David?
Thanks, Scott. Thanks for having me again. It's a great joy to hang out with you and with everyone here, and consider many of them friends. I have some bad news, though. We still have not worked through all 5,000 mineral species yet. We're still working on this. So
that's good news.
Hang in there with me. We're getting, much of the way done here, but at some point we'll go back to pure astronomy here. But this is planetary science, and it's looking at how the universe likes to make planets, if you will, with these pure minerals. And so I'm going to go through a few more tonight, and I'll share my screen, and I will see if I can share a slideshow, and I'll see if I can start a slideshow. And we'll see if we're in business then. Can you see a big red crystal?
Yes.
That is not what we're going to talk about tonight. That's rhodochrosite. That's just a placeholder. And tonight we're going to talk a little bit about magnesium and calcium minerals, which are fairly common minerals. And we'll show a few examples of those. Those are pretty common elements as well. But first, before we do that, we'll talk a little bit about what minerals are, again, as we always do. Thomas Jefferson long ago said, "I believe in a divinely ordered universe." Before his time, even Isaac Newton, one of our founders of modern science, gave us the quotation, "Truth is ever to be found in the simplicity, not in the multiplicity and confusion of things." The universe is ordered not by supernatural design, but by the principles of physics. We don't need to invent crazy things. As Richard Dawkins likes to say, we don't need to magic things into existence, but understand the way science works in our world, and that's what brings things together, even minerals. They demonstrate that because their atoms are assembled in precise ways by electrochemical attractions. That's what brings them together, that are inherent properties of the atoms that make them up and guide them into assembling into what mineralogists call a crystal lattice. And that makes up these minerals in specific ways and specific forms, just as we, as citizens of the universe, who are made of the stuff, as we've talked about many times, that are elements that are created in the explosions of massive stars, or the collisions of massive stars, or the deaths of low mass stars. All of that stuff makes up the approximately 7 octillion atoms in each of our bodies as well. So when we look at minerals, we can look not only at what makes up Earth, but we know that spectroscopy tells us that chemistry is uniform throughout the universe, of course, and so we can imagine that many of these substances are combining in similar ways on other planets throughout the Milky Way and the at least 100 billion other galaxies that exist in the universe. So one of the things we'll look at tonight, just for a little change of pace, is magnesium making up some minerals. One of the many, many common minerals that counts magnesium as a principal Constituent is brucite, that's magnesium hydroxide. It was named in 1824 by Francois Boudant in honor of Archibald Bruce, who was an early American physician and mineralogist, and he was editor for many years of the American Mineralogical Journal back in the day. It comes in many, many colors: white, light greenish, grayish, bluish, honey yellow, brownish, deep red brown. It's a member, not surprisingly, of a group of related minerals called the brucite group. And we can look at the crystallography of brucite here just very quickly. It's trigonal and contains magnesium, oxygen, and hydrogen atoms. That magnesium hydroxide there that you can see in the simple ball and stick diagram. So we'll look, as always, at a few examples of things that show some magnesium and some calcium minerals. Again, these are kind of mixed up a little bit because these are kind of how I photograph things in various shelves in cases, so they're not quite cleanly sealed off. But this is brucite here, which gives you in many examples this kind of seafoam blue-green color in the mineral. This is from a famous mine in the Kalahari manganese field in South Africa. And you can see this kind of color that you often get. And I'll just kind of walk through some other related minerals that are largely magnesium or calcium rich here. Another one from the same area here in South Africa is called sturmanite. This is calcium, iron, aluminum, manganese sulfate, tetrahydroxyborate. So there you go. You know, we're getting some large numbers of elements involved here. And those are the kind of caramel colored crystals here that are on the dark stuff is a really manganese rich sort of country rock, if you will, that the crystals are on here. So this just gives you an idea of the similar or the same chemical elements, just arranged differently with some companions and giving us really, really different looks, even though they're made up of fairly similar constituents here. How the universe likes to make planets. So this is a mineral. It's a fairly common one as well. It's a magnesium mineral called amesite. This is a chromium amesite, and the chromium gives it a sort of a purplish color here, but you can see there are little triangular crystals here. This is magnesium aluminum silicate from a fairly well-known region in Russia. And quite a common magnesium mineral is spinel here, which is also fairly dense, and it's sometimes even used for jewelry and so on as well. It's in some pieces of marble here. And just to show you the same mineral being contaminated with little what mineralogists call chromophores, that are some random atoms that color the minerals differently, even though they're the atoms are in small numbers relatively, giving spinel here from Myanmar, as Kramer would say, you know, in the old day, or Seinfeld, that's Burma to you and me. But that's magnesium aluminum oxide. But spinel from a different locality here in Kenya that's almost identical is bluish from different contaminants here. So also in a chunk of marble here. So little subtleties can change the look of minerals very dramatically, even though they're very similar constituents. Just as people, all the people and most all of the life on Earth is almost nearly identical in terms of DNA, but we have a great range of different looks and differences as people if we could only learn to get along, because we're almost identical. We can put that out back to that mine in Russia there, perhaps. This is boracite, which is magnesium borate chloride from a famous old-time mine in England here, which gives you these sort of light green colored crystals here, fairly common mineral. This is a nice one too. That's a mineral called clinichlor, and this is chromium clinichlor. It went by the name for many, many years of camomorite. This is magnesium aluminum silicate hydroxide from a famous region. This is the only really good region where you get this deep purple, sort of a grape juice, purple colored crystals of this mineral in Turkey. Ferrierite, magnesium rich, are these orange things that look like little things that might come alive in an early episode of Star Trek when the props budget wasn't so large yet. This is magnesium, sodium, potassium, calcium, aluminum, silicate hydroxide. There's a 3-ring circus of elements there in this one, with some other associated minerals from a fairly well-mined region many years ago in Italy, in Sardinia. This is a weird one. It's a fairly common mineral as aggregates, as little clumps of crystals called cordierite. However, this is a gemmy variety of this mineral that's called iolite. It's nicknamed iolite. This is magnesium, iron, aluminum silicate. And what's weird here, especially from this region in Madagascar, is that you can cut it and slice it and polish it as this cube has been polished and cut. And that shows, if you could turn it here and look at it closely, it's what mineralogists call and physicists call pleochroic. That is, it appears violet blue in color along one axis and golden yellow along the other axis. It's perpendicular. So very odd optical properties of some minerals exist. Here's another somewhat uncommon mineral, magnesium mineral called batriogen. It gets its orangey and yellow color from iron mostly that's in it. This is from a well-known mine in Argentina. This is a rare mineral called grandidierite. That's another magnesium mineral, and it's rare in this kind of gemmy, again, seawater blue-green color, another mineral from Madagascar. It's a fairly recent find of the last decade or two. This is an unusual mineral, although it exists in nice crystals in many specimens, called creedite. This is from a domestic mine in Nevada here. It's a calcium mineral that gives you these sort of deep violet crystals often. And this is a colorless, not terribly exciting, some mineral collectors think, but one of these colorless minerals, a calcium mineral called hydroborosite, which you can guess is borosite that's hydrated. And it's from a German location as well and gives you these nice needle-like or acicular crystals. Here's more borosite. This is an unusual one from Bolivia, and those are the orangey crystals there that are dipyramidal from a Bolivian mine. This is stichtite, a magnesium mineral from Australia, just again giving you a range of color and crystal types here from more or less the same elements, all of these. Lazulite is a very deep, rich, deep blue mineral. The best specimens of it come from the Yukon in Canada here, and there are a couple of other associated minerals here with it. This is an Indian mineral. There's a region in India that contains a large number of hydrated minerals that is a vast storehouse that has millions and millions of specimens. The interesting mineral here is cavensite here, and the very common mineral is the white stilbite, but the sky blue stuff or peacock blue stuff is called cavensite. It's another calcium silicate. And here's yet another fairly common one that's often found in the same Indian location. This one's from Morocco, however, another calcium mineral with these blocky cubic crystals called chabazite. And again, that just shows you, a great range of colors and types of minerals of basically the same constituents, but arranged in different ways and forming, of course, with different temperatures and pressures and chemical blends and so on, give you this incredible range of colors and shapes. And as Scott said early on, we're excited this year because we're going to have the 6th Starmus Festival for the 6th time. We're going to be focusing on the theme of Mars and how the first Martian missions, that is Mars 3 from the then Soviet Union and Mariner 9, the United States, just a little over 50 years ago, made it to Mars and started to give us our modern view of the red planet. We will have many, many speakers there. We're just about on the cusp of announcing a huge array of additional speakers. There are some astronauts and some astrophysicists and the founder of Starmus and the famous Jill Tarter, and even ordinary guys like me will be speaking. We also have some rock and roll there because we want to use both halves of our brain, both hemispheres, as we like to say, the science and then having some fun. And so there'll be some rock and roll with some of our friends who are on the board, like Brian May and Rick Wakeman and Peter Gabriel and others. And Mr. Scott Roberts will be coming along with us and putting on a huge star party. We think we'll have 1,000 or more people at the star party out of the 3,000 people at Starmus. Scott, I think you're going to bring a dozen or more telescopes along.
Oh yeah, and we're joining up with a local group of amateur astronomers there as well. So that's going to be a lot of fun. So if you're thinking about coming to Starmus, maybe if you can bring a grab and go telescope, you can join us in that star party. So
it's actually pretty easy, believe it or not, to get to Armenia. If you can get to Europe, it's not much more than that in terms of the travel, logistics, and cost. And the festival, because we think we'll have 3,000 to 4,000 people there this year, and there are many students in Armenia, and we want to make it available to them, physics students and others. So it's going to be really, really cheap this time. And the Armenian government, believe it or not, some governments are interested in promoting a good society and making life better for everyone. And believe it or not, the president of Armenia, who's helping to arrange Starmus, is a physicist. So we had a chemist who was the most senior politician in Germany. Now we have a physicist who is the president of Armenia, and he's helping to sponsor this, and we're excited about it. So if you can get over there into that part of the world in September, you will have a fantastic time with us. And if not, you're going to hear about all this stuff: astronomy, Nobel Prize winners, astronauts, and I think there'll be some famous rock and roll people there giving a talk with me and playing their guitars as well. And you'll hear about this afterward if you can't join us in person.
yes, that's great. Well, David, thank you so much. I'm really, really looking forward to Starmus, and it's going to be absolutely fantastic. As soon as I come back from Starmus, I get ready for the Arizona Dark Sky Star Party, which is something that we hope to have David Eicher speak there as well. So we're going to be some exhausted astronomers, I think. But it's going to be a lot of fun, and we're really looking forward to all of this.
If this is Tuesday, it must be Arizona, we'll be thinking. Or if it's Saturday, this must be Yerevan. We'll be thinking one or the other. Yeah.
Oh, yeah. We'll be upside down with all that. But that's okay. That's okay. It's been a long time coming. So, yep. Well, great. Thank you so much for coming on with us, David. And we are going to reintroduce Robert Fugate, who has asked me to call him Bob. So, Bob, I really appreciate you coming on to Global Star Party again. This is your third time. We were joking that if once you get past a dozen of these things, then you can actually never leave. So,
okay.
So we're, but
all right. I certainly appreciate the hospitality and the other talks. I've really enjoyed the other star parties I've been to, and have actually looked up some old ones on YouTube and find them all very fascinating. So
thank you.
I think this is a great service. So thank you very much for doing it.
Thank you. Thanks for coming on and sharing your knowledge and passion with us. Thank you.
Okay, I'm going to try to get my screen going here, and So this might fit, this first location I'm showing here might fit right in with David's talk. This is the Bisti Wilderness in northwestern New Mexico. And I show it only because I tried to shoot a lunar eclipse there in 2015. And it's a very unique kind of place. It is a wilderness area. You can only hike to get wherever you're going. It's very large. It's quite easy to get lost, and there's no cell phone coverage. And so one needs a GPS, a really, an actual GPS device that that you can plot directions and maybe even some maps. So this is a kind of an ancient forest area, I guess. It has lots of petrified trees, very large ones, and lots of erosion and hoodoos and just unbelievable kinds of rock formations. Like I said, it's very large, and it is useful to go there with someone. Don't go out there by yourself if you do go. And it's quite the place to reflect on the universe, on your life, on most anything you'd like. I went in 2015 with a friend here in Albuquerque, and they have no facilities. There's just a fence with a gate and a parking lot. And so you're all on your own. And we wanted to get to a particular place that was several miles in, and we wanted to be there at first light to get the correct light on our landscape. So we started hiking before sunrise, and that's really scary. It's very dark there, but the sunrise was just gorgeous. And this area is very popular for astrophotography, for doing nightscapes and so forth. And there have been a lot of really kind of famous shots. This one was an astronomy picture of the day in 2020, actually.
Yeah.
And I think it also won some Astronomy Photographer of the Year award. Marcin Zajac is the photographer. And so it's just an incredibly cool place that that you should take an opportunity to visit if you can. So when I was there in September of 2015, there was a lunar eclipse. And of course, we're talking about shadows tonight, and I wanted to share some of my eclipse shots. This is a shot from the parking lot, actually, and you can see in the foreground here the fence and the gate and a little sign reminding you that this is wilderness and abide by the wilderness rules. So this was the night before the full moon, and I just wanted to get, just kind of capture what it looked like, before it got really dark. And here's the night of the beginning of the eclipse. It's just awesome to be in a place like this and witness a total eclipse. And I want to point out, if you can see my cursor,
yeah,
I want to point out a little bit of coloration on the edge of the umbra there, and that's due to ozone in the atmosphere. And so I want to show you later the umbra and the ozone, and just keep that in mind. In 2018, I went to a place northwest of Albuquerque, about 35 miles, called Cabazon Peak. This is a core of a extinct volcano. It's similar to the one made famous in the movie I can't remember what it's called now, something tower, Devil's Tower maybe. But this one is just not quite as tall. So this is an image I made before the lunar eclipse, and it's illuminated by the full moon. Here you can see maybe Orion to get you oriented. And this was in January of 2018. And then when the moon got over and got into the Earth's shadow, we got this picture. And the cluster next to it here is the Beehive cluster. You know, there seem to be a lot of eclipses around Beehive. And I tried to orient my location so that as the moon set, it would go right behind the peak here. And I was pretty successful. I got this shot. And this was almost at sunrise. So the lighting has changed a lot. And, you know, there's a lot of pink in the sky and so forth. So that was one thing that I messed up on was when the moon got fully eclipsed and it was dark, the coyotes started howling. And it was quite the chorus. I mean, it was unbelievable. And I kick myself now because I should have just turned on my phone and recorded it. Because it was really quite something. They were, you know, either upset about the fact that something had happened to the moon, or they were enjoying it, maybe both. And then last November, we had this partial eclipse. It was really close to the Pleiades, and I shot this one in my backyard. And then in 2019, I went down to Magdalena. Now this is John Briggs's place, and this mobile dome here is up on the hill behind his house. And so I went down there hoping that you know, I would be able to witness a dark sky. As I drove down, there were all these clouds around. You can see the clouds, and actually in the left corner here, you can see the moon. Try to put my cursor over here on it. It's barely visible in the clouds. So I was really kind of disappointed, but as the evening went on, it got more and more clear, and except for some very high thin cirrus, which was kind of cool because it made the stars a bit bigger, and you really didn't see it unless you took, like, you know, a fairly long photograph. But at any rate, this was my setup here. It's an old mount, and I haven't used it so long I've forgotten what it's called. I'm sure you all recognize it. It's a NEQ6 mount, and I had borrowed this Takahashi Epsilon 180 ED, which is a f2.8 Newtonian. Camera is on the other side. I had a D850 mounted to it, and then I had my laptop here on the card table, and then I had a tripod with some other cameras. So I wanted to, everybody of course understands this, but I wanted to, here's a NASA graphic on the shadows cast by the Earth during a lunar eclipse. And the dark part is called the umbra, and the other part of the shadow surrounding that is the penumbra. And so I wanted to try to capture some images to visualize that, and this is what I came up with.
Wow.
So what I did here was, through that telescope, I took 7 or 8 stop HDR images as the eclipse progressed. So this is at the beginning, and you can see the umbra start to come in here. And so then I had this series of images, which I processed as HDR. I put them in Photoshop in layers, and I rotated them so that the curves lined up so that you can visualize the umbra of the Earth's shadow in this picture. And it gives you a feeling for how big the shadow is in comparison to the size of the moon.
It's huge.
And then at the height of the total eclipse, this is the actual orientation of the moon in the umbra at that time. And you'll notice it's a little brighter on this side than this side. And I think that's maybe because it's closer to the edge of the umbra, you know, rather than being, it's rarely goes through the center. So, so it's rare that the illumination on the moon is uniform. But the bonus here is this blue ring. And the blue ring comes from ozone in the upper atmosphere. Ozone, the peak concentration of ozone is at about 35 kilometers above the surface of the Earth. And it's, of course, not very dense, but it has a strong absorption for wavelengths, visible wavelengths, longer than about 500 nanometers. The absorption in the red is several hundred times higher than it is in the blue. And so what happens is the blue light gets through, you know, from this layer, and the red does not. And so that's why when you see pictures like this one on the, you know, just before totality here, you see a strong blue tint, and that's caused by the ozone. So while I was taking these pictures, I was setting up another camera and with a wide angle lens, because I wanted to try, my goal was also to try to get, you know, a starry sky with an eclipsed moon. And so I got this shot.
Wow.
And this is a composite. It's actually, you know, a couple of pictures put together. You can see how the stars are sort of bloated here, and that was because there was some remnant of subvisual cirrus at high altitude that kind of softened the stars and enhanced their color. So I thought it was kind of cool. But when I looked out and saw the moon, the eclipsed moon, just hanging there in the cosmos, it just really blew me away. I mean, it's just like three-dimensional.
Yes.
And so I worked to try to get a photo of it. And here's the landscape that's just east of Magdalena there at John's location. So that's kind of what I had to show about shadows.
That's beautiful. Bob, the image that you have of the, that presentation that you have of the Earth's shadows against the moon.
Yes.
How did you separate those exposures? Were you able to make lots of exposures and then just pick one?
Well, yeah, I mean, I took exposures every few minutes, right? As the eclipse progressed, I just took more and more, you know, I was actually on a cadence so that I tried to get them with some similarity,
right? Some
progression. But each time I took one of those pictures, I took an HDR set. So I exposed for a lot of different times so that I would cover the, you know, several stops that exist between the illuminated part of the moon and the shadowed part of the moon. And, you know, it's like 7 stops between an eclipsed moon and, you know, one that's not eclipsed. And so then I just processed each set of those HDR images and put them in layers in Photoshop on a big canvas. and then I just moved them around, I looked up, I found out how big the umbra was, and I, made a little graphic in Photoshop, a circle, and then I, for each layer, for each image, I just moved it into place and rotated it and lined it up with the circle so that the shadow, the circular part of the shadow lined up with the circle that I had on the graphic.
Just an incredible display. I mean, it becomes, it's an astrophotograph that is also a visualization.
Right.
So that, and it just conveys, that one image of all of that just conveys so much information. And to be very honest, it's the very first time I've ever seen it done. So it's beautiful and inspiring. And I think a bunch of people are going to try that.
Okay,
on
well,
this next eclipse coming up. So
And
very
I
cool.
just wanted to add that I really did enjoy the different eclipses that you photographed over the years and the different appearance of the moon. And one of the interesting things that we're going to look forward to on the 15th is the luminosity of the fully eclipsed moon. There's actually a scale called the Danjon scale that you can use to determine the luminosity of the eclipsed moon, from L equals 5, where it's a very bright coppery red, to L equals 0, where the moon just almost disappears. And we might be having an L2 or 1 this time, for the simple reason that we have had some major volcanic eruptions in the last few months. One in an undersea volcano near the Hawaiian Islands put a lot of dust into the Earth's atmosphere, and then one just recently did the same thing. And with all that dust, we might get a dark eclipse this time. The darkest one I've ever seen was December 30th, 1963, was an L equals 0. At mid-totality, I couldn't see anything where the moon was supposed to be.
amazing.
Yeah, thank you.
Okay, great. Thank you.
Great. Okay. Well, thank you again, Bob, and I hope to have you on future Global Star Parties. I think you're raising the bar for each of us every time, so I really appreciate it.
Okay, I do plan to get out into the New Mexico desert for this eclipse, so hopefully it'll be clear, and hopefully I'll be able to operate my equipment in a way that brings forth a new image.
Great. Wonderful. Okay. All right. So, and thanks again. Our next speaker is Samantha Jewett. Kareem Jaffer, Professor Kareem Jaffer from the Royal Astronomical Society of the Montreal Center is going to introduce her. Samantha is also very involved in astronomy outreach with the Royal Astronomical Society of Canada. So we're going to learn a lot more about her. I'm really happy she made time to be on this program. Very happy that Kareem introduced her. So Kareem, I'll turn this over to you.
Thanks, Scott. It's great to be back. And before I introduce Samantha, I actually wanted to take a few moments, if that's okay. I wanted to share an in memoriam. Samantha and I are on the National Education and Public Outreach Committee. And one of our members from the Sudbury Centre in the North Bay Astronomy Club here in Ontario, Canada, Linda Puglia, just passed away suddenly this past weekend. And we are heartbroken. She was one of the first people I actually met in outreach at the RASC back in the 2019 General Assembly in Toronto when David was doing his biography talk. Linda had just brought the Sudbury Centre into the RASC. And Sudbury Centre joined us in May of 2019. She came to our General Assembly to represent them, joined the Education and Public Outreach Committee at the same time that I did. And we were just, we became fast friends. She was a Girl Guides leader for a long time, really runs and organizes a lot of their members and public outreach star parties in the national parks in Ontario, Killarney Park over in North Bay area near the lake. And it's a big loss for us nationally, as well as especially for the Sudbury and the North Bay Centre. So I thought a great way to memorialize her for us is the way in which I remember her most fondly, which is at our last online GA, she and I decided to do an entire comedy routine to start off the Education and Public Outreach Center. So I have a few jokes for everyone to help remember Linda. So Scott, David, I think this is right up your alley. Why does a moon rock taste better than an Earth rock?
Oh.
It's a little bit meatier.
Ah!
Do you know what the astronaut said after his first meal on the moon base since the Artemis is taking us back there?
I have no idea.
The food was good, but the place lacked just a little atmosphere. This one is especially for David Eicher. Why should you never trust an atom?
Oh, you got me.
They make up everything.
Oh.
No.
All right, one more. One last one.
One more.
How do you know when the moon is going broke? It's down to its last quarter.
Oh.
Very nice. Very nice.
You see why she's going to be missed. Those were some of her favorite Astro jokes. So I thought this is a good avenue to share them.
That was
And
awesome.
That was good.
Samantha and I have both been privileged to work with Linda, and she's been working on developing a beginner's outreach certificate that our public outreach members, when we have an audience that just comes out for one night, it gives them a chance to look for a couple of things and get a little sticker or something on their way home to say that they've learned a little bit about the night sky. So that's the project that Linda was working on last, and hopefully that'll be available at the RASC by the time the fall rolls around and we're hopefully really back in person in full. Now, Samantha and I have been working on another whole set of projects that she's going to talk about with you tonight. She's our RASC outreach coordinator, our remote telescope guru and whiz, and just an all-around awesome astronomer / astrophysicist in training. She does have her degree already, but I'm going to say in training because she still has to get out there with the telescope for us to see, like, you know, her navigate the night sky and show us that she's star hopping and all the wonderful fun that we talk about every Tuesday night. So Samantha, tell us all about what the RASC is doing right now for the Artemis mission outreach.
Thank you so much for that wonderful introduction, Kareem, and thank you for sharing those kind words about Linda. I echo them completely. She will really be missed. So as Kareem said, we have been working on, sorry, let me just share my screen so you can see some lovely pictures in addition to my face. Sorry, my screen's loading. Let me share my screen.
It's just the lag time from the moon to here. That's all it is.
Oh, where are we? I am so sorry. I don't know why. I'll share my whole screen. Okay, here we go. You see all of my windows. I apologize. So
there we go.
The big project we are working on is celebrating humanity's return to the moon. So we have a number of celebrations, but before we dive into this, I'm going to tell you what I even mean by humanity's return to the moon. So why are we even celebrating? Well, the CSA, the Canadian Space Agency, approached us and said, we want to get the public excited about something called the Artemis program. Now, the Artemis program, that name sounds familiar, Greek god, is the sister program to Apollo. Like Artemis is the sister to Apollo. It took me too long to get that. It was embarrassingly long, and now it makes so much sense. However, this is the next stage in deep space exploration and lunar exploration, but I say deep space exploration because it's going to lead to so much more. It's led by NASA, but through the Artemis Accords, there is a variety of space agencies across the world. As you can see, all the symbols down below. As I said, the Canadian Space Agency is a part of it. We are contributing our knowledge in a lot of our robotics. And this is just all the space agencies have come together to agree on a way to peacefully and collaboratively explore space. and starting with Artemis mission. So exciting thing, this year it launches Artemis 1. The Artemis mission is in stages. So Artemis 1, they're testing out everything. They have a brand new launcher. They have a brand new capsule called the Orion capsule, which is about the size of a minivan designed for 4 astronauts. So I don't know if I'd want to live with 3 other people in a minivan for the time that they're up there, but kudos to the astronauts. This is why I appreciate them, and I'm glad they're going up there and not me. But Artemis 1 is doing kind of a loop around the moon to make sure everything works. And that is happening. They're hoping in June this year. Now, we all know how space travel goes. It could be pushed back, but it's only been pushed back by a couple months or weeks recently. So like the James Webb, like it feels like it's actually getting close. Artemis 2 is going to happen in, I think right now is estimated 2024, but don't quote me exactly on the dates because they change. And this is the first crewed test flight. So it's going to do a similar thing as the Artemis 1 mission did. It's not going to actually land on the moon, but it's going to fly around the moon. Cool thing for Canada is we're going to have an astronaut out there. And this is the furthest we've gotten because we weren't heavily involved. We were not involved in the Apollo missions. And then finally, Artemis 3, which is hoping to be happening in the year or two after Artemis 2. We'll have the first person of color and the first woman to step foot on the moon, which is so exciting. This is just super exciting with these 3 missions. But on top of that, we're not gonna like just go there and come back like we did last time. We're building a base there, starting with building a space station about 1/6 the size of the ISS. When I say we, I mean humanity as a whole, because I like to think of us all together working towards this. It's going to orbit the moon, and it's going to be a base, a waypoint for eventually, if we do more deep space travel, be a waypoint for the module I told you that takes the astronauts from Earth. It'll go dock to here, and then they'll use this point to go back and forth from the moon. So what are they going to do on the moon? Well, lots of experiments. We are building a base camp, or in my brain, I like to think of it as a really decked out, tripped up camping site on the moon. So no more just a flag. We are having experiments. There will be rovers. We are going to explore the South Pole to look at liquid hydrogen, oxygen, and water. And there's just collaboration from all over the world to do this. This is like the ISS, but further. And this gives us the opportunity as well to learn about what we need to do deep space travel. With the ISS, we can just ship all our food, but we're going to be farther away. And if we go to Mars, we are too far away to keep on shipping supplies. So we're going to do experiments of how to grow our own food on the moon and how to use the resources there. So this is kind of not only to explore, learn about the moon and Earth and everything, it's a stepping point to learning how to travel deeper in space. So everybody's like, why do we go back to the moon? We already did this. Well, this is a place that's familiar, quote unquote familiar, but a place that gives us the challenges that we're going to have deeper in space. So incredible decade plus of stuff coming up. I am so excited that I am getting to live to see this, because everybody knows I'm a little young to be alive during Apollo. The last Apollo missions were 50 years ago this year, so twice my age. But it's just so cool to see us doing this again. So I said that is why we are celebrating. How are we celebrating? Well, the RASC, or the RASC, is doing several things. First of all, we want to educate people on how to view the moon and learn about the moon themselves. That's what we're all about, amateur astronomy, getting out there, looking at the sky. As Kareem said, I was an astronomer in training because really the only thing I can expertly look at is the moon, but I learned so much just looking at the moon, and I love it. This is my photo with my cell phone camera, which is not as beautiful as Bob's, but I'm very proud of it because it was one of my first times I took the telescope out by myself.
Sure.
So we have several resources online. Let me see if I can get to them. So I will just show you very quickly what we have here. We have all about this Artemis program. If you want to look in deeper, talk about NASA, there's online resources to learn about this and the moon in general. We also have Indigenous knowledge that we've sharing from other Indigenous educators. We have a list of helpful books. We also have we have done all of our webinars. We put them in one place to show you how to view the moon. walk through that. Tips and tricks. We have a whole half an hour. I think there's 10 or 12, 8 episodes that goes through how to view all these beginner targets on the moon. We have target lists. So what even look at the moon? And we also have certificates. So if you are an RASC member and you complete our moon certificate, you get a lovely pin. We tell you about useful apps and websites. I even painstakingly made a map with our target list for every single lunar day and every single view. So if you want to know what is on the moon that lunar day, find your lunar day, and those are the targets you'll be able to see in telescopes or binoculars.
That's great work.
And we also have resources to learn how to sketch the moon, because it makes you a better observer. If you look and start sketching what you see, you really start to notice more details. And I found that while I was and continue to go through our list of lunar targets. We even have reference images here for you to test. I will go into what the Sketching the Moon webinar is more about. So you can find all that at rasc.ca/moon resources. All free. You don't have to be an RASC member. Just check it out if you want to learn more. So on top of learning about the moon, we want people to share their views of the moon. We are accepting submissions from anyone. You can be a video. It can be what you're sharing a 30-second video about what you're feeling about first seeing the moon, a video of that you've taken of a moon. It can be pictures, it can be drawings, it can be anything. We want to see what you see when you look at the moon and you feel. And that is at rasc.ca/sharing-moon. So these are some submissions that have already come in. We are using these, we're sharing them on our social media, as well as a webinar that I'll get into. This was done by an 11-year-old. It is amazing. It's pastels, gorgeous. And they've submitted it. I love this photo.
That's amazing.
Sorry. This is from one of our outreach people. I started talking to her about this and she said, hey, the moon was the thing that got me into astronomy. I took these in high school with a film camera and developed them with my teacher. And she said, nobody really did. I just took it with my camera up to the eyepiece, and she still had these. She didn't tell me how many years later, but I thought these are really cool. And then we also have just gorgeous astrophotography. These are just 3 of many, and we're still accepting submissions. So if anybody has beautiful views of the moon they want to share with us, please do. We are launching again for the 2nd year in a row, a specific creativity program for youth ages 5 to 17. We're expanding the age group this year, called Creation Station. It's basically anything you can send digitally to us, that a youth can send digitally to us. So it can be short stories, videos, comics, drawings, multimedia things, collages, poems. We are sharing on our website as well, and we're collecting them. And it doesn't just have to be about the moon. We do have a specific section for the moon, but this is anything space related. And Kareem is one of the masterminds behind this as well. You see, he's got his hands in everything. And these are 2 things we got last year. They are mixed media. We have a poem with a wonderful drawing, and we also have a plasticine and drawing of an astronaut. So another way we are selling the moon is, as all of us amateur astronomers do, is have star parties. We've connected with RASC centers all across Canada. They are both hosting online and virtual star parties. It's already gone underway through the month of April, in the first 14 lunar days, when you could see them, or the first days you could see the moon during the evening, because we weren't going to hold a star party at 5 a.m. Fortunately, we're lame like that. And they've been online and in person. I want to share with you a couple of the online stuff that you can go back and watch. RASC Toronto had an excellent one. They had a speaker that talked about the Artemis missions. They showed live view of the moon. They had reflections from one of the RASC Toronto Center's daughters. You can find that at RASC Toronto's YouTube. Another one that Kareem and I were both involved in, we hosted Bettina Forget. She's the SETI Artist in Residence Director. And she's just an amazing artist. She has this whole series of Women with Impact, which are craters named after women. This is one of her images from that. But she taught us in an hour session, she only drew for a half hour, how to sketch a lunar crater. And you can go back and rewatch this. Great tips on what drawing materials to use, where to start, and just to do it and how it makes you a better observer. We had some sketches from, as you can see, Jesslyn is a very experienced artist and all the way to David Lee, who had never drawn a moon crater before, and this is what he got out of it in a half an hour.
Jesslyn is actually a youth. She's 17.
Oh my goodness.
That's really nice.
We have some talented people here. Like, oh my. So these are gorgeous things. So if you just want to know the basics, 10 out of 10, watch that webinar. It's one of my favorite ones I've ever participated in and been a host of. I'm sorry, all the other webinars I've been a part of. And as we all know, International Astronomy Day is coming up on May 7th, so we got to do a lot of stuff. If you are located in Canada, I really encourage you to look up your local RASC center and see if they are doing anything. I know a number of centers across Canada are doing things on the Friday and Saturday, and most of these are in person. Some of them are the first time these centers are doing things since COVID restrictions lifted. So great time to get out and view through a telescope. But if you can't, we are hosting, and this is for all our international folks too, we are hosting our Shooting for the Moon webinar, which is a webinar just celebrating basically what I told you about, but views of the moon across Canada, because we are located in Canada, as well as just how the moon in general and where we're going. We've also connected with Astrofest in Montreal, who is hosting Canadian astronaut David St. Jacques for a talk. And so they're doing it in French there. And the CSA is live streaming his French talk online as well. But we are offering an English, a pre-record version of that talk in English for the people who cannot join in on the talk at Astrofest in the Planetarium Montreal, followed by a live Q&A. So we are going to tune directly into the Planetarium Montreal, and there's going to be a mix of live and online questions. So we're going to be gathering questions from our audience and slightly ahead of time for the people who've registered to ask questions. Then we are going to hop in after all of that to a national live stream. We have reflections from people who remember Apollo and where their journey to viewing the moon now. We have, I think, it ballooned today. I think 6 different centers from across Canada showing us their live views and parties that are happening and just tuning in. And we are going to share that moon content I was talking to you about and just talk about Artemis in general. So I encourage you to register. It's via Zoom. We're going to live stream on YouTube at 8 p.m., but the David St. Jacques section is only via Zoom just because of the technicalities of it. So bit.ly/shooting for the moon. And if you want to learn more about anything I've talked about, it's all in one place, rasc.ca/Artemis parties. You can always also go to rasc.ca and go to the contact page, find us, find myself. I'm sure if you Google me and RASC, I will come up. And we hope you can join us and just are excited as we are about this next stage in lunar exploration. Thank you.
Scott, you're still muted.
There we go. I'm unmuted now. I thought I was going to sneeze, and I did not want everybody to have their ears blown out if I did that. But apparently, for some mysterious reason, I didn't. So anyhow, Samantha, thank you so much for coming on to Global Star Party. I know that that you have a very busy schedule, and so if you can find any time in the future to come back on, we really would appreciate that. So thank you.
Thank you. I'm sure Kareem will find a way to get me back on.
I'm sure he will. Okay. All right.
I'm
Hope you enjoyed it. Thank you. Okay. So next up is Molly Wakeling. Molly has been on lots of global star parties in the past. She has a program called AstronoMolly's Universe, and we always enjoy her take on the science of what she images and her beautiful astrophotography. She dives into also explaining how she makes those astrophotographs. a wealth of knowledge, an extremely talented astrophotographer, and the first winner of the Wilhelmina Fleming Astrophotography Award by the Astronomical League. So it's great to have you on again, and thanks for joining us on the 92nd Global Star Party.
Thanks, Scott. I'm glad to be back again. I've been away for a little while. My schoolwork has got me very busy, but Scott finally just texted me and said, "Hey, you should come back on." And my cat is also interested in being online tonight.
Yes.
I think he just wants to be fed, as always. Yeah, so let me, I was going to share my screen, but he's sitting right in front of the button. Okay, you need to go over here. Thank you. This is Orion, by the way.
Perfect name.
I put up a picture of one of my lunar eclipse takes because I wanted to share it, but I didn't focus my talk on it. So I like this one. I'm very happy with it.
Absolutely. Beautiful.
Thank you. All right, here we go. Oops. There we go. Okay. Yeah. So thanks, Scott, for having me back again, and taking the light and shadow in a little bit of a different direction. I decided to talk about the Iris Nebula. So the Iris Nebula is a combination reflection dark nebula region. It's illuminated by a central star, and the dust reflects some of that light, as opposed to an emission nebula like the Eagle Nebula or the Swan Nebula, or a lot of stuff in Cygnus that absorbs ultraviolet radiation and then re-emits it as this deep red light. Instead, this dust is reflecting the blue light from the central star, and it glows blue as opposed to red or blue from oxygen. And the dark nebula is made up of light absorbing cold molecular dust, which I have a slide on a little more on that later. So if you want to go observe or photograph the Iris Nebula, it is up just off the edge of the constellation Cepheus or Cepheus. I've heard it pronounced both ways, I'm not sure. Which in the good time to see it in a northern sky is actually not when it's oriented this way, but when it's oriented upside down, when it's up high up above the North Star. So over here, this is the star on the edge of the W of Cassiopeia, to kind of orient yourself there. And so it's opposite Cassiopeia on the opposite side of Cepheus from there, kind of halfway between the two bright stars of Cepheus and a little ways off to the side. So yeah, so that's where that's located. So some fast facts about the Iris Nebula. It's actually, the nebula it has a higher, is brighter magnitude than the central star, actually, because of all the light that it's reflecting over a larger area. At magnitude 6.8, it's pretty bright. It's 1,300 light years away and about 6 light years across, so quite large. Not as large as some emission nebula like the Rosette Nebula, which is like 150 light years across, but that's a lot of gas and dust being lit up by one star and something that is 6 light years across, which is, depending on how you measure the width of the solar system, at least 12 times the width of the complete solar system, and more if you just are counting from the sun to Pluto. The molecular dust contains organic molecules, and some of those organic molecules are quite large. When you don't really think about there being organic molecules floating out in space, but that's one of the constituents of these dark nebula, are some of these larger molecules that I'm going to talk about in a couple of slides here. And the blue glow in the center is, so that the star that's at the center of there is a hot young star. So it's still glowing very much in the blue part of the spectrum, just like how a really hot flame from a propane stove is blue, and emitting tons of energy, dumping that into the nebula. So I like to show what the objects I talk about look like in other wavelengths besides visible light. And there's not a whole lot of images that are done in other wavelengths of the Iris Nebula, because it's mostly optical and some infrared. So I have a piece of software called Aladdin that is sort of like planetarium software, but more for like framing targets. And you can also see it's got a whole database of every kind of data that has been taken on some part of the sky, everything from radio to gamma rays and lots of other information as well. So when I can't find pictures online, I'll go over to the Aladdin software and load up some of the databases and see if I can find an image in some of these wavelengths. So the image here on the left is I couldn't find like a real radio wavelength image that wasn't just huge pixels. So this is more microwave, almost getting into far infrared. Yeah, it looks funny just because this is like a patchwork of data put together here. The image on the right is far more interesting. This is Spitzer telescope data in the infrared. So if you go back and look at, this is a monochrome image of it, you can see how we can't see through part of the dust cloud. And infrared light allows you to pierce through some of those dust clouds and see a lot more than you would be able to see otherwise, and get some really interesting information out of that. Looking at the UV database, this is the best one I could find there, which is only a partially cut off picture of some overlapping fields of view in near ultraviolet. So it is, again, this is a hot young star, so it's emitting a lot of blue light, which means it's definitely emitting lots of ultraviolet as well. So just really bright in that ultraviolet channel. And over on the X-ray side of the house from XMM Newton, pretty much you can just see some of the star sources that are in there. These are probably newborn stars that are being formed in that nebula. All right, so digging into a little bit of science, a good thing to talk about with the Iris Nebula is molecular dust clouds. So a lot of nebula like the dark parts of the Trifid Nebula, and a lot of these dark nebula you can see in Taurus and intermixed in places like Cygnus. It's all made up of what's called a molecular dust. And a lot of that is actually molecular hydrogen, which I have a picture for down in the lower right corner. It's two hydrogen atoms that are bonded and they're sharing electrons. It's actually different from like the covalent and ionic bonds that you learned about. It is a specific hydrogen bond that makes it very stable and very symmetric. You also find a lot of carbon monoxide, which is useful for helping us detect where the hydrogen is, because molecular hydrogen is really hard to detect. But wherever there's molecular hydrogen, there's also carbon monoxide. So we can look for where the hydrogen is by looking at the carbon monoxide, which does emit light. I think it emits some infrared light. I think it emits some radio light as well. And on the much larger organic molecule side of the house, the heaviest organic, or I guess I should say the largest organic molecule that has been observed is something called benzonitrile, which I have the chemical formula here: carbons, hydrogens, and nitrogens, a lot of organic stuff there, and other aromatics, which is types of organic molecules that I think aromatics are the ones that form kind of ring structures, if I recall. It's been a while since I had chemistry. So yeah, lots more than just than hydrogen. There's a lot of organic molecules up in these dark molecular clouds too, which is really cool. These clouds are very cold. They're not absorbing and then re-emitting ultraviolet light, because a lot of these molecules, they're emitting energy from vibration and rotational states, which are much lower energy than something like an excited hydrogen atom. And and so they tend to be about 10 Kelvin, which, if you don't speak Kelvin and speak Fahrenheit, is negative 441 degrees Fahrenheit. It's just a few degrees above absolute zero. And in Celsius, that's negative 263. The particle density of these molecular clouds, basically how many grains of dust, how many, how many of these molecules, it can be 100 particles per centimeter cubed or more, which can sound like a lot, but that's still like a pretty healthy vacuum. But it's enough of a concentration that the reason we can see a lot of dark nebula is because it's blocking out the light from the stars behind it. Molecular clouds are where new stars are born. That molecular hydrogen eventually through gravity starts to coalesce into a star. And so our star was born in a nebula like the Iris Nebula. And as I mentioned earlier, they don't emit optical light, but they do emit down in like the radio microwave kind of millimeter area due to the molecules vibrating and rotating in these specific energy states that when they change will release some energy. The picture on the bottom is the carbon monoxide map of the Milky Way, kind of showing where these molecular clouds are located. And yeah, they're all over the place. This picture here is a picture I took of the Snake Nebula when I was at the Texas Star Party, which is this guy here. Got some really cool shape. And I also kind of see like a bowl here. So that's a lot of fun. Yeah, so if you want to observe, oops, I forgot to change the title of the slide. Observing the Iris Nebula, as opposed to the Snark Nebula in general. This is for my last talk. So a good time of year to observe the Iris Nebula is unless you want to be up early in the morning, June to December is a good time when you can catch it before midnight up in the northern sky. So I'm not sure if it's at a low enough declination for some of our southerly observers to be able to see. It may be pretty low on the horizon for them at certain times of the year, if it's above the horizon at all. But for the northern folks, it's actually circumpolar for most of us. So yeah, there's always a time to go check it out. The star and the reflection part of it are relatively bright. And so you should be able to see that from more light polluted locations. I haven't actually visually observed the Iris myself. I'm kind of making some guesses based on other types of similar nebula. But if you want to be able to see the dark nebula against the background of stars, you're really best doing that out at a dark sky site where you can actually see those background stars and then see them being blocked by this dark nebula. It's not particularly small, but it's not very large either. It's about 18 by 18 arc minutes for kind of that main portion of it. So good to look at in longer focal length scopes like Dobsonians, but you could also look at it with refractors. It's still a pretty decent size. Photographically, you can do it in some light pollution. In fact, I'm following a thread on the I think it's on the ZWO forum on Facebook about somebody trying to image, I think it was this nebula, trying to figure out how much dust they'd be able to pull out from the background from the city. Something I haven't had much luck with, but it is better photographed out in dark skies where you can see, again, just like in visual, more of those stars in the background and be able to actually see the dust better against that background of stars. Larger field of view, you can catch a lot more of the dust because there's dark dust everywhere around this area. It's not just concentrated around this star. So there's lots of stuff to be caught in the background. But you can get lots of detail on the core with smaller fields of view, so with longer telescopes. I do want to note that if you are a narrowband imager who likes to use a lot of narrowband filters imaging from the city, even though there's a lot of blue light here, this is not oxygen blue light. This is reflection blue light. So there is pretty much no narrowband light here. So you want to do broadband. So your red, green, blue filters or using a one-shot color camera without a narrowband filter. And of course, I have to show off my favorite picture of it. And this is actually one of my top 10 favorite pictures. This was done out at a dark sky site back when I lived in California. And this was done with my Takahashi refractor, which is 530 millimeters of focal length. So it's actually a really nice target for shorter focal length. And this would actually make a really cool target even for camera lenses, because there's so much dust going on here in the background. This was about it's like a 5 hours, 20 minutes of exposure time. So when you're out under dark skies, you can get away with much shorter exposures because you just get so much light coming in that's not being overridden by the light pollution. And yeah, so this was done in a Bortle 3.5 sky, and I'm very pleased with it. And anytime I can get color out of the dust, getting this nice brown and being able to see kind of different color gradations, I'm happy and real happy with how this came out. So yep, that's what I got.
That's all you got. That's pretty amazing.
Any questions from the audience or any questions on YouTube?
People are saying beautiful images. Dan said the snake looks like the design from the Teal'c's head in Stargate.
So I have a question.
Yeah.
I'm imaged from my backyard in Albuquerque, which is pretty bright, and I have like 20 hours on the iris, but I don't see much color in the dust, and I've always worried about the color of the dust. You know, is it mine is like I don't know. I could show it, I guess, but it's just kind of gray.
Yeah. So when I've tried to image anything with dark nebula from any kind of light pollution, even from Bortle 5, I've struggled to get any color out of the dust. And I on the Facebook forum that I was reading, I made this point on there, but then people made a counterpoint showing images that they've done from Bortle 6 and Bortle 7 where they actually got color in the dust by doing 20 or hour plus exposures. So I don't know if I'm just not good enough at processing yet or what, but I've always struggled to do dark nebula from the city. But with 20 hours, you may be able to eke some out. You may have to go and play with the color a little more. With my iris nebula image from a dark sky site, I didn't have to work hardly at all to get that color to pop out because I wasn't fighting the background. But some people showed that it can be done from the city. So
let me, while I've got you and you're the expert, let me try sharing my screen.
Sure.
And you can look at it.
Oh yeah. Yeah, that's actually quite nice.
Very nice.
But you know, it doesn't, and I asked some of the local astronomy club guys, you know, because they seem to get more color. But
yeah, I don't know. Yeah, I mean, you did get quite a lot of dust there. Yeah,
well,
I think maybe your best bet would even be to I don't know how exactly to isolate the dark nebula, but to mess with the color temperature of the image.
Okay.
And maybe mask out the stars in the core when you do your color temperature change, so that those stay accurate. But you may be able to redden the dust a bit by
so the dust really ought to have a more yellowish brown color, you think?
You know, I've been asking myself that question because mine came out that way. I've seen a lot of other people's come out with this brown red color. I don't actually know how accurate that is. I wouldn't expect the dust to have color, but yeah, well, it does have some red in it actually. The dust that is near stars, there is some hydrogen emission going on from hydrogen atoms that are not bonded to molecules. Most of the hydrogen is going to be bonded, but there is some hydrogen emission that will go on when it's being energized by a star. So yeah, I guess there is some red in there from that, but I think having it be gray is also acceptable from an accuracy standpoint.
Okay, I'll try to do some more work on it.
That's a nice image, though. You got a lot more dust than I've been able to. So awesome.
Great. All right. Well, thank you very much, Molly. I hope to see you again. Probably not on the next Global Star Party because I know how busy you are.
Yeah.
But of course, you're always welcome. And thanks for an amazing presentation. Thank you.
Yeah. Thanks for having me.
Okay. All right. So up next is will be Dan Higgins and Pete from Astroworld TV, who have popular programs on YouTube, but they are. I've been on their program before. They're fantastic, and they really get people, take them to the next level in their astrophotography through their presentations, through their insight, and through working through all the little problems that can attack astrophotographers as they learn their craft. So, Dan, thank you for coming on. Let me get both of you guys on the Dan and Pete show. There we go. And let's add on Pete. Pete Myers, here we go.
There you go.
There we are. You guys have the stage.
I got a black. Can you see me? Because I have a black screen. I'm sorry.
Yes, we can see you. You are
Okay, cool.
Yep.
How's it going? Thank you, Scott, for those kind words. I mean, we really try and keep it light on Astroworld, as you know. We have a bunch of people that constantly just come back, and a lot of people that are in your audience now. I gotta tell you, speaking of the mistakes that we make and the dark nebula, as Molly was talking about, I got the big mistake, and I'll premise this right now. If you've watched the show, I love to make fun of myself, so I may as well. And one of the other co-hosts, Eric, was imaging the Dark Shark Nebula, and I said, you know what? Let me give it a shot. I've never done Dark Nebula before. Let me give it a shot. Now, prior projects before, all I've done really is narrowband. I'm in a Bortle 8+ guy on Long Island. It's pretty horrible. And so I set up my sequence, and I done, ready, go to bed, let it run all night. Let me see what I get in the morning. I go in the morning, I open up a picture, I got nothing. What I forgot was to switch my sequence from narrowband to broadband. So I got 8 hours of the Dark Shark in H alpha. So I got nothing. So I thought that was kind of funny. Peter, you there?
Yep, I'm here. How you doing, Dan?
I thought you heard. Good. Yeah, so Pete is one of the members of Astroworld 2, and he is with me tonight. Pete, why don't you talk a little bit about what we do?
Well, it's kind of interesting is that basically it's really just a very informative, kind of giggles and laughs, very, very intuitive. We definitely have reached out to a lot of guests, including Scott, you've been on, as well as we've got a multitude of guests from Bob Denny.
A lot of fun.
And it's interesting is that typically we'll have anywhere from between 50 and 60 viewer members on. And the nice thing about what we've got is we've really started to kind of take this to the next level. It's to the point now where people have really started to tune into the Astroworld show. We've gotten a lot of good feedback. We've gotten a lot of good gifts and drawings. And I think this whole Astroworld is a testament to the detail that Dan has put into making this, it's kind of like the hardest thing is getting it started. And once the inertia takes over, it kind of just perpetuates itself. But kudos to Dan for initially starting this Astroworld show, and it's really just taken off the year lately.
Yeah, and it's been really it's been a lot of fun. And one of the things that we do, and I don't know if I could share my screen. I think I can. Let me just share. Let's see. Yeah, I could just do it right on my screen. So one of the things that we do every week, now that we got it all sorted, is a picture of the week. And it's not a picture of the week based on the aesthetics of the picture. It's partially because of that, but it's all based on the voting of their peers. This is not something that we take in the 5 of us or the 6 of us look at it and we pixel peep and we do it. No, this is all about the picture and how the peers look at it. So we throw it online, we do a voting, and we announce the picture of the week every week. And if I could show a little bit of some of the pictures that we've had, let me see if this pops up. Can you see that?
Yep.
Okay, so this is one of the pictures, that one picture of the week from Andres. I can't pronounce the last name. He is from Europe. He's one of our members. And then we got Mark Ellis, who had the Veil Nebula. This was the most recent winner from Ro Ophiuchus. This is from Jason Trevino, who won the picture of the week that week. And we have a bunch of pictures that have won across the past couple of months. And what we're doing now is we're taking this, and at the end of the year, what we're going to be doing is making an Astroworld calendar that goes out to the membership with all the pictures of the month, because we'll be doing a picture of the month as well. So I think that's going to be kind of cool.
Yeah, the nice thing is that, and as I said, once again, this is a testament to Dan, is that we do 2 shows a week. It's on Wednesdays and Fridays, typically the Wednesday show will start at 6 p.m. Eastern Standard Time, and then the Friday night show is at 5 Eastern Standard Time. So typically I'm just finishing work and Dan's already got a couple hours playing catch up. But typically the hours on the show, Dan, where they go, probably between maybe 2 to 3 hours.
2 to 3 hours, depending. If we stay on target 2, but we usually don't, we kind of the comments in the peanut gallery and in the chat boxes kind of throw us off the loop, and sometimes we throw ourselves off, and we call that off the rails, and we do that every once in a while.
Just to get an idea of some of the guests we've had on, we've had Charles Bracken, who is the author of the Deep Sky Imaging Primer, and Charlie absolutely just had a blast, and he truly wants to come back a second time. We've had Dr. Christian Sassy, who is general manager of iTelescopes. Bob Denny, who is actually going to be getting an award at the AIC show for what he's doing on alpaca. He absolutely had a ball on the show. I mean, it really is just a very informative show. And as I said, we've got a lot of guests lined up. And we've got people that truly just want to step up and say, hey, I've heard about the show. How do I get on it?
And let's not forget all the astrophotographers out there. Sean Nielsen, Doc Ron Brett Preacher, Warren Keller, Pete Proul, Adam Block, and Molly. You're next, by the way. I'm going to be calling you up because you're going to be next. So we have a huge amount of people. Doug Struble, TJ Conley, Simon Lewis. I mean, we've had a bunch of people on the show. So I mean, it's been a lot of fun.
It's such a small community, this astrophotography, and it's interesting is that when I look back at when I'm started, Scott, you and I have shared this last time we were on the show and how you got started. We really didn't have this kind of a forum to be able to tap into and get information. I mean, literally, we had to go out there and
it was
read
hard.
it. It was hard. And so, I think that now with the technology, with the cameras, the fast optic scopes, this really is the golden age right now for people that want to take pretty pictures, let alone for scientific and citizen science. I mean, we really are.
Either way that you want to go. I mean, it's all right there. And made all the better because of the kind of community that amateur astronomy is. It's such a sharing, giving community. If you want to go from point A to point B as quickly as possible, there's just no better community to be involved with. And then you enhance that with shows like yours, or being able to do something like Global Star Party where people around the world can connect. I think it's awesome, I
was thinking, Dan, it's a shame that you couldn't come out to AIC this year because it's going to be on a Friday, Saturday. It would have been a perfect time to do the Friday show at AIC.
I know.
Literally walk around, but it's not to say that in 2 years there'll be another AIC, so we have to plan that.
Yeah, absolutely. And I'll be doing a live portion of the show when I'm at Cherry Springs come a month from today, I think is the weekend. So I am so excited to go to Cherry. It's been 3 years. I'm so excited to finally go to a dark sky spot that's under Portal 8. I might be able to do some one-shot color. Who knows? I don't know.
Maybe that's true.
Maybe. But it's a lot of fun. We got the members and the people that come week after week and day after day on the show are really what makes the show. And it wouldn't survive without everybody showing up. And I got to show thank you to all of our people that support us. So, and if you don't know anything about us, you can go to www.astroworldweb.com. You can look at all the pictures of the week winners. You can look at all the guests we got coming up. I think tomorrow, right? Tomorrow.
Yeah.
We have Richard Wright from Starstone Software tomorrow night. So that's coming up. Then we got Eric Coles coming up on the 13th from the Astro Imaging channel. So he's going to be coming on. It's going to be a lot of fun. We got a lot of people coming up. So
fantastic. That's great. Well, guys, thank you for coming on. We do have just a few minutes left here.
Absolutely. Yeah.
Anything else that you'd like to discuss before we go to our 10-minute break here?
No, just come to the website, check us out tomorrow night, and we'll be there every Wednesday and Friday night. Wednesdays at 9 Eastern and Fridays at 8 Eastern.
Some of the hardest working guys in astrophotography are right here, so that's awesome.
Well, I appreciate that.
Okay, well, that's great. I want to take just a couple of minutes here to thank all the people that have been on this first segment. We had David Levy, Carroll Orge from the Astronomical League, David Eicher, editor-in-chief of Astronomy magazine, talking about minerals and crystals of magnesium and calcium. His collection is just so intriguing. Bob Fugate showing just astounding images of the lunar eclipses, and I loved the image. I loved all the images, but one that's now sticking in my mind beyond the one that showed all of Earth's shadow, with the circle of moon images. There is the one where it looked like the moon was just like rolling off the bluff, so it was just I kept imagining what that might look like hung up in my house, like a giant 40 by 60 inch metallic print or something.
That'd be awesome.
So really beautiful. So Samantha Jewett, who is astronomy outreach assistant at the Royal Astronomical Society of Canada. Very cool. Molly Wakeling with AstronoMolly's Universe. We all love that. It's great. Of course, Dan Higgins and Peter Myers. Coming up next will be Michael Carroll, space artist and science fiction writer, author. He has provided actually more than a couple of books. We're going to give away. These two books here that have, they're signed editions of two of his science fiction books here, Plato's Labyrinth and Living Among Giants. And hopefully you guys are entering into the Astronomical League's contests, and you'll be offered to select one of those books if you so choose, if you win. Up after Michael will be Cari or Karina Letelier. She is in Chile. She also does amazing nightscape astrophotography. You're going to want to watch that. Marcelo Souza down in Brazil will be joining us later on tonight, and Norm Hughes joins us. I think he's in the background here, been watching on as we've been running this program. Cesar Brolo with Caesar's South Sky Universe. Maxi Falaris, if he's still not freezing to death, will be on with us. And then, of course, Adrian Bradley with his beautiful nightscapes. So we've got more to share, and we really appreciate that you have joined us and are watching on the Global Star Party, our 92nd edition. So let's go to break, and we'll come back in about 10 minutes. Well, hello, everybody. This is Scott Roberts at Explore Scientific and the Explorer Alliance, and you've been watching the 92nd Global Star Party. We're now into our second part of the Global Star Party, and up next is author and space artist, illustrator Michael Carroll. And Michael has, as I mentioned earlier in our program, Michael has donated a couple of books here. Actually, there's a couple more that we'll also be using to give away for some of the door prizes that the Astronomical League coordinates. But these books are beautiful, and you know, I would have read them myself, except that I just didn't want to get my fingers too much all over them, you know, and start underlining them as I do with books. But you'll see that they are beautifully signed. And anyways, really happy to have Michael Carroll join us. And let me bring you on, Michael.
Okay.
There you are. There you are. Perfect shirt as well. You got your moon shirt on. You got your moon. Is that the moon behind you as well?
That is a moon. That's Ganymede back there.
All right. Well, wonderful. Well, you said you'd take 5 minutes to talk about your artwork, your books. Please take a little bit more than that, because we're really happy to have you here.
Well, thanks. It's great to be here. Let me share my screen. And I will see if we can get this to go. Okay. So I'll just give you guys a few comments about these books, but in doing so, we can talk about some interesting things about the cosmos in general. Living Among Giants is really a nonfiction book about how we are going to explore and ultimately settle the outer solar system. We've been looking at Mars a lot lately. Throughout my career, Mars has always been, human exploration of Mars has always been 20 years away. But with things like Artemis and some other breakthrough technologies, I think that it's really possible that Mars is going to be happening in manned spacecraft exploration soon. And that means that we need to take a look even further out. The outer solar system is full of resources, natural resources for us to use and utilize as we explore further. And the question may cross your mind, is it even realistic to talk about travel to the outer solar system with humans at this point? It took Cassini, I think, 7 years to get to Saturn. That's way too long for people to go sitting around twiddling their thumbs and watching DVDs. But look at these, notice these numbers. At the turn of the last century, in the late 1800s, early 1900s, the average family in Europe or the US ran on essentially 2 or 3 horsepower. That's how many horses people owned on average. Half a century later, we had aircraft that ran on 1,000 horsepower. Half a century after that, coming up to about now, we have Airbus 320s and Boeing 737s that operate on almost 100 times that. They're equivalent to the combined armies of Genghis Khan in an aircraft. And these things take off, 737s take off every 2 seconds around the world. So there's a lot of advances in transportation. It is reasonable with this curve to think that in half a century, we may have ways of getting out there. There are some cool, creative propulsion systems that are being studied. And so we cast our eyes out to the outer system. Of course, you can't land on a gas or ice giant, the big balls of atmosphere with very dense cores, but we can, if we want to hang around out there, deploy giant balloons and even build balloon cities, science stations to float among the clouds of these gas and ice giants. What's really fun to think about, though, and a little bit more practical, is exploring the satellites around them, the natural moons. The problem with the moons of Jupiter is radiation. You can see that on Io, you get a deadly dose of radiation in a few minutes. On Europa, you get it in 8 hours. Ganymede and Callisto are a little better targets, but it sure would be fun to explore Io. Wouldn't it be great to run across all those volcanic flows and look up at the plumes? Well, there are places that we could go that are sheltered from that radiation pouring from Jupiter, and they are lava tubes. A lot of the eruption sites on Io are attached to lava tubes, and you can go down there and there's not much energy coming through. So you can imagine hanging out there. The problem with a lava tube, of course, is that sometimes they refill, and that would not be good. Europa, next one out, the ocean moon. We would love to go there as well, and it's a little bit easier. And of course, it's got 100-kilometer deep ocean. Who knows what's down there to explore in the future? Callisto is one of my favorites. It's got these ice towers. Imagine being a tourist and looking up at these great pillars of ice. Ron Miller shows us a view of tourists on Enceladus out at Saturn. Of course, we'll have tourists eventually at Titan, where you can, the gravity is 1/8 what it is here. It's less than the moon. And the air is so dense, you could actually fly under your own human power. And you can also go sailing, or take a boat out, a submarine, maybe surfing. So in the future, traveling to a world like, for example, Saturn might be a lot like our cruise ships in the Aegean Sea or in the Caribbean, where you have day trips to various different islands, and then you go back to the mother ship to move on. So one day we'll have tourists, I think, standing at the shores of these great methane seas on Titan, or the deserts of Pluto. Living Among Giants talks about the practical ways that we will use to get out to those places. And I know we have some physicists with us. I know Kareem and background, and so the other book, Plato's Labyrinth, is especially for that kind of discipline. It talks about quantum physics. Of course, we who look at the sky are interested in the where it all came from, the universe, how big it is, how old it is. The Planck satellites has given us an incredibly detailed view. This was from Wilkinson. This overlay now is from Planck. Some astrophysicists, quantum physicists, believe that there are bruises in the universe where other universes are bumping up against us, tying into the multiverse scenario. James Webb Telescope, of course, is going to help us to lock down not only the size of the universe, but its age. Plato's Labyrinth just talks a lot about not only quantum physics, but its fallout, as it were. Here's a guy talking to himself. I'm from the future, you left the toaster on. We also touch on Waterhouse Hawkins, who was the world's first dinosaur sculptor. He was commissioned after he did a series of dinosaurs in England. He was commissioned in 1870 or so to do some for Central Park. But because of some politics, his dinosaur statues were destroyed before the public could see them, buried in Central Park. And to this day, no one knows where they are, but people are still searching for them. So Waterhouse Hawkins, a very colorful person that novel visits. And it also deals with Atlantis, that great continent that Plato talked about. Many of the characteristics that Plato mentioned for Atlantis are actually found in the Greek island of Santorini. It may have been a historical description of Santorini at its eruption, 1600 BC or so. This is what it looks like today, with 10 times exaggeration vertically, but there are all kinds of guesses as to what it was like back when it was Thera, the hub of the great Minoan Empire. So it's fun to take science and turn it into a novel form. That's what Plato's Labyrinth does, and other books in the series by Springer called Science and Fiction. A bunch of novels that have a section at the back for the science behind the story. So hopefully those will be enjoyable to you guys.
Wonderful, wonderful. That's great. So, Michael, how many books have you written?
I'm working on number 33.
Wow.
It's a book comparing different stages of the Earth developmentally to other planets. So,
wonderful.
Let's see if I can stop sharing here. I've lost my cursor. Almost got it.
Here, I can stop your sharing. It's easy for me.
Can you? Great.
No problem.
I will. My cursor.
No problem. I like the little like drop and some other things.
Yeah,
what does it all mean?
Good, huh?
That's great. So, Michael, how did you get fascinated by? I mean, I would think anybody would be fascinated by the universe, but what was your tipping point? What drove you into a lifelong journey into doing all this?
Well, aerospace kind of runs through the veins of my family. My grandfather was a major general in the Air Force and kind of in charge of experimental aircraft at the end of World War II. My dad was an aerospace engineer, and one of my earliest memories is going out back in a nice, pristine Colorado evening with him, and we were looking up at the stars as they'd been plastered across the sky for eons, except for one of them. One of them was moving, and he pointed up at that one and said, "That is Echo 1. It's a big balloon that they bounce radio signals off of." And I said, "Why do they call it Echo 1? And he said, "Well, because there will be more." And of course, he was right.
Amazing, amazing. Well, you've given us a great evening here with your beautiful artwork, your illustrations, and some lucky winner of your books will be really diving into them. So I hope you come back very soon, because we're going to be giving away 2 more books. And I'm trying to read one of them, Lords of the Ice Moons, and I cannot see the other one right here, but
I think the other one's Drifting on Alien Winds, which is about the weather.
I think you're right.
Weather on other worlds. So yeah.
Wonderful.
Well, thanks, Scott.
Wonderful. Thank you so much.
Well, it's been a great evening. I will hang around for more great discussion.
Yeah, wonderful. That's great. Okay, so our next speaker is Karina Letelier. Did I pronounce that right, Karina?
Yeah, perfectly.
I think your volume is a little low.
Can you hear me now?
Perfect right now. Perfect.
Great.
Okay. Yeah. So Karina lives in Chile. Where is it that you live? Are you in La Serena, or where are you?
Right now, I'm in Santiago, the capital city, but I live in Temuco, in the southern part of Chile.
And you do wonderful photography and astrophotography, and so I imagine you're going to treat us to some of this tonight. But tell us a little bit more about yourself.
Okay, well, my name is Karina, like the constellation. It was just a coincidence, but a pretty good one. I have 35 years old, and well, I'm from Chile. I'm an industrial engineer. Actually, I also have a master's degree in logistics and a graduate certificate from MIT in logistics also, but I quit my job around 4 years ago to dedicate myself 24/7 to astronomy popularization and also to astrophotography, landscape astrophotography.
Wow, that's very inspiring, and a brave leap for someone to take. Because you have the comfort, the security of having a nice job like that, but or jobs like that. But what was it like to say, okay, this is my last day and doing this and going full time into astronomy outreach?
Well, it was kind of it was pretty scaring because most of the people tells you, how are you gonna live? How are you gonna make some money? And I was, I keep telling everybody, I want to wonder how to earn money, how to generate money, but I really want to do this. I mean, I really want to wake up every day doing this, sharing about the night sky, sharing about different landscapes and nightscape, and use the wild field astrophotography as a tool for astronomy popularization. So yeah, it was kind of difficult. Actually, my boss, I told her, hey, please fire me because I want to start living from this. And I need some money to start with this because I don't know how I'm going to do it. She told me, I believe in you. So yeah, I'm going to fix this. And she fired me. So I got
fired.
this. Yeah, I got fired for astronomy.
Wow. I think you're the first one for me to meet that got fired for astronomy. So
really?
Congratulations. I think that the world of the worldwide community of astronomy will benefit. Your images are breathtaking. I told you, and you know this, I give a lecture on occasion to astronomy clubs and stuff, and it's called the Power of Astronomy. But I was really inspired by Karina's images of people out in front of the Milky Way, and of course my talk is all about the transformative experiences that people have in observing the Milky Way, and that healing effect that it can have, the way you can get a new perspective on your life, the universe, your place in it, all of that. And Karina's images are not only poetic, but they're beautiful. So I'm going to let you show your work, Karina. Thank you.
Okay, thanks to you. But I gotta say that I got so inspired by you, Scott, when we got that talk, that lecture about the power of stargazing. And it was mind-blowing because you talk about so many things that I didn't know before that start like, it was like a puzzle that all the pieces start like, like
Connecting.
It was so exactly. Sorry about my English; is a little rusty.
No, no.
I don't have the chance like to practice my English here every day. So
You're doing just fine.
You're doing perfect. No problem.
Yes, we can understand you clear.
Thanks a lot. So I will show you some of my work and some of the Chilean night sky. Give me 1 second just to share it. Okay, so as I told you all, I'm trying to use the landscape astrophotography.
It's still in the screen sharing. It says double click to enter full screen mode.
Oh, there it is. I think I already fixed it. Yes. Great. So as I told you all, I'm really trying to get to use the astrophotography, the wild field or landscape astrophotography, as a tool for astronomy popularization. As you know, this is the most similar to our wide view. When we use the wide angle lens, you know, it's more similar to our view, to our eyes, how our eyes are watching. So the people is like, you're turning on a switch to watch what is invisible. You're photographing what is invisible to the eye because of the, you know, the limitations that our eyes have. So, well, about this picture is in the Atacama Desert. I was telling today earlier to Scott that it was such a mind-blowing night sky. It was, I'm pretty sure it was about to -1 because it was so mind-blowing that you were able to see your own shadow, the shadow because of the bright of the stars. So wow. Let me just continue. As I was telling you, I'm an engineer. I quit my job to dedicate myself to this about 4 years ago. And I work with Astrophotography at Chile, and we're trying to make more people fall in love with the night sky, with the stargazing, with astrophotography, deep sky or wide field. That's what we're doing. Normally, we don't know how to call it, like if we're satanizing or something like that, but we're converting astro lovers. We're converting more people to watch up rather their feet.
Yes.
This is, this is our staff. Well, we try to create very new ways for disclosure, for astronomy disclosure. So we make tours, we make workshops, we make astronomical and astrophotographic camps with people that really wants to learn about this, and they really believe that they don't have the skills to make this. So what we're trying to do is to tell them, hey, anybody can watch to the stars. Is something open to all of us. It's not just something private. It's not something that you have to spend like a lot of money. It's just, you just gotta get very far from the city, you know, all these light pollution hubs, and start watching up. And it's easier to connect with the night sky when you know it. So what we try to do is that, to teach people about a little bit about the night sky so they can know it, they can protect it. You can't protect something that you don't know. That's basically what we do. And we also developed this community of astrolovers called Cazadores de Estrellas, that is the star hunters, to all the people that really wants to start stargazing or astrophotography, and don't know more people involved in this. You know, this is like, some people call us weirds or nuts or crazy people because we really like to be like outside in the field with the cold and very sleepy and not so comfortable, but we don't care about that because we're connecting, watching to the stars. So, well, we invite all the people to join our community and to keep converting more people to astrolovers. These are some of the activities that we organize with Astrophotography at Chile. we try to also work a lot with ancient cultures from here, local ancient cultures, and study the astronomy. They had to plan their lives, like when to hunt some animals, when to start, different things in their lives. What else? Let me just go on. Well, and as I was telling you, we really have to struggle with astrophotography as just landscape photography, but because we really want to get the people into the astronomy by this tool. I mean, it's not just the landscape, but it's the landscape with the night sky. It's not just to take that photo, it's to know what you're photographing in there, what it is in there. Actually, all this recognition of the constellations of the deep sky objects, I make it all manually. And to all my students in the workshops, I encourage them to do exactly the same with their photos, to know the night sky by their photos, through their photos. About light pollution, I just wanted to get in context about the worldwide situation. 83% of the world population and more than 99% of the US and European population lives under light polluted sky. It's like, many people doesn't know that you are able to watch in the night sky the Milky Way. That here in the southern hemisphere, you're able to see the largest galaxies at the naked eye, like the Magellanic Clouds. They're huge. I have friends from Colombia that when they came to Chile, they cried when they saw the Magellanic Clouds, because to see those very big galaxies just at the naked eye is mind-blowing. And here in Chile, here in Chile, we have less than 1% of the population living under very dark night sky, and around 30% of the population doesn't live in night skies where they can be able to watch more objects, more deep sky objects. They just can see like very bright stars, like, the Southern Cross or Orion, but no more than that. So they don't know what they're missing. Well, about my work, this was my very first photograph, and it's such a bad one, but it's like, it's like your first child. I don't have children, but the first one, even if it's ugly, you love it. Mine is very ugly, but I love it because it was the first one. It was my very first photo. What you see in the corner is light, I don't know how to say it in English, sorry, but it's not a meteor. It was something from the public luminary. And the one in the right is in Atacama, in the mountain range of the Mexico. And it was the very last photo I made. So it's beautiful. It's not impossible to reach like a more quality in your work, in your photos, or even in the knowledge you have or someone had about the night sky, but it's to be constant, to keep going to the field, to watch up and to keep practicing. I think since I quit my job, I have been studying more than when I was in university. I keep studying like every day about different things in astronomy, in photography, to keep developing these skills that I have, that they're nothing if I don't study and I don't keep practicing and learning more. So anyone, it's able to reach their goals if they really put their heart into it. So about light pollution in Chile, as I told you, more than 30% of the people live in places where artificial light does not allow us to see the stars. This is so sad because people are very used to watch their own feeds or their own cell phones, like the very Black Mirror, because they don't have the chance to watch up. Actually, the last video that I show you, this one about light pollution, is a time-lapse made in Dubai, one of the largest hub of light pollution. Actually, I went to the desert of Lahbab, near to Dubai, and it was so light polluted. They were so proud about the night sky they had, and they turned on all the lights off. And they told us, all the people, the tourists in there, told us, and now please watch to the stars. But it was such a bad night sky. It was Bortle 6 or 5, something like that.
Yeah, so that's a big challenge in so many places, not only for human beings, Karina, but for all animal life. You know, they all need the dark.
Exactly. Actually, in here there are many places that are under such a great night sky. For example, in the Maule region, we have a place called. I have a photo in other slide that is a place that is under Bortle 1 night sky, and there is a project, a mining project, and also an energetic project that it's gonna screw everything. They're gonna kill that very good night sky. Well, about the astronomical tourism, I think we have a huge opportunity in here that people are not taking advantage of that we have some of the best night skies in the world. We really try to use this as an engine for the development of people of tourism, but we really need more support in this part. We really try to encourage more people to make astronomical tourism, as we really need more hands in this, showing the stars, teaching how to watch to the night sky. I gotta say that most of the people that is making astronomical tourism is because of the photo. They want the photo with the Milky Way behind. They're not really taking this kind of tourism to know or to learn about the night sky. Is because of the photo. But after the tour, they get so much more than just the photo, and they say it's like, hey, I was here because of the photo, but now I know where's the Southern Cross, and with that I can just orientate myself and know what is the south, the north, the east, and the west, and it's all because of this tour. These are some of the opportunities that we have in here, making a mix with different kind of tourism, mixing with astrotourism. For example, with different ethnics, different ancient cultures from here, with stargazing, without the stargazing, I mean, not using telescopes, even there are some companies making trekking, like during the night, to watch different landscapes on the night sky, or using binoculars, or I don't know, making horse riding during the night. It's just to be innovative. It's just to be more creative, to mix it and to make it more attractive for people. It's not just the technical part. So this is some of the other opportunities that are here in astronomical tourism. Because I wanted to get to this about the Chilean night sky. So, you know, here why we have this very good night skies is because this privileged latitude, we are in the very end of the world, you know. So if you go to the Atacama Desert, there are places where you can see the major Ursa, you can see it all out. Actually, I have a photo of Ursa Major with reflection in Laguna Elegía. And it's amazing to be able to watch objects and constellations from the northern hemisphere from here. But if you go to the southern part,
wait, that's not fair. We struggle to see Crux, and we can't see it up here. You can see Ursa Major from your latitude and the height that you can get to in Chile. Yeah. I quit. I have to come to Chile. Sorry. It's a very beautiful presentation. I'll talk more later, but I had to complain. You can see Ursa Major. That's amazing.
Yeah. Yeah, that's the cool thing about Chile, that we have so many, it's such a large country that you have so many different views from the night sky. For example, if you go to the southern part, you're able to watch the Milky Way during January, very, very early during the morning, but you can see the galactic core during January, and it's like mind-blowing. And to watch in the transition night sky, for example, during autumn or the fall or during spring, that you can see Scorpion with Orion together in the night sky. It's so mind-blowing when you know the night sky and be able to see that kind of phenomena. Like they're together. Oh my God, it's so nerd for some people when I am in those transition night sky, and it's like, wow, I gotta make the panorama now because I have both out. I have this very wide landscape, and I can have both in the night sky, in the same night sky.
Again, I wanted to say unfair, but I already knew that happens in the Southern Hemisphere. We have our folklore about why Orion and the Scorpion don't stay in the sky at the same time, but that pretty much breaks the folklore right there, because they're in the sky at the same time.
You're welcome to come to Chile.
Yeah, I'm working on it right now, actually.
Yeah,
Carry
you might
on.
want to skip Okie-Tex and go to Chile.
Yeah, I'm thinking that would be a better
and then on
drive.
to Argentina.
Yep.
Well, what about the night sky in Atacama Desert? You know, is the driest desert, right, in the world. So that's why they have these very perfect conditions. These very perfect conditions to stargaze, to observation, to astrophotography. Actually, there was a time I was making astrophotography with a friend. He was with his telescope, and the scene was so perfect that he was able to make to use his equatorial mode for, I don't know, it was photos of 15 minutes of following, because the scene was so good. It was so dry that the sky was just perfect.
Very stable.
Yeah. And well, also in the Atacama Desert, you have more than 300 nights a year with no clouds.
Man.
Yeah.
Yes, you could easily become an insomniac in Chile with those night skies.
Yeah, it's difficult to think going to sleep with these night skies.
Yes. Yes. Yeah, and I know what you're talking about with seeing the large and small Magellanic clouds. Seeing them so big, it is such a surprise to see how big they are, in the sky.
Yeah.
Because photographs always look like two little patches, but when you're under this night sky in Chile and you see that, it's just, wow, very large, very big, very impressive, much brighter than I expected, so it's, but of course I was at CTIO observatory complex. It was also very, very dark, so it makes me smile to think that Chile wants to become the astrotourism capital of the world. And and that would be safe haven for any astronomer that wants to experience this. So, Cari, I think that you're going to be able to make a lifetime career doing this. And, we're all encouraging you to keep on.
We're struggling to get it, but we always say that since we how can I say it? Most of the people that is working with me in this project, we all quit our jobs to dedicate ourselves to this. So now we are poor, but very happy, It's like poor just financially talking. I don't have a house, but I do have my car. And with my car, I can move wherever I want to go. And I can have the chance to get this kind of night skies. For example, this is zodiacal light, that it was so bright that one of the person that was there with us was telling us, hey, is that the sun that is rising? No, because it was just 4 a.m. So the sun was rising at 7 a.m. It was so bright that for this time it was not difficult to catch it. This was in Antofagasta. And that was, this is about the north. This is also part of Atacama Desert. These landscapes that are so, how can you say it, like oniric landscapes that mix it with the night sky and this very bright air glow that you can see all very green or very orange because of the air glow. But that's not all, because we also have other places. If we start coming to the south, we have the center north part of Chile that where's the Elqui Valley, but the Elqui Valley is not the only one that have very great night skies. For example, this is pretty near to Monte Patria. It's another location in the Limari valleys that have excellent night skies, and they have so much richness in culture and archaeological things. For example, they have many petroglyphs, geoglyphs. Most of these are located strategically aligned with the night sky. For example, there is a stone that have like holes, and these holes, they used to put water on it. So they use it as astronomical mirrors to reflect some constellations. There is a rock that have all the holes are in the form of Scorpion. So during the winter, when the Scorpion is in the zenith, it's reflected in each of these holes when they put water on it. So they knew that they were very close to the New Year's for these people. For example, Diaguitas or Incas, that they celebrate the Inti Raymi during the equinox in June 20. And with this kind of this art in the rocks, they knew it, how to predict it. Well, this is also under the, it's in Cochihuas Valley, another valley pretty near to the Elqui Valley. It's part of pretty near to the Elqui Valley, that it's really mind-blowing. Bartle 2, night sky, the air glow was kind of orange and green that time. And I don't know if you can, oh, there is the Magellanic Clouds. You have both in there.
Yeah.
And well, this is also some of the places of the ancient cultures located in there that are strategically oriented with some night sky phenomena. For example, where you have the moon rising during the winter or during the summer, and you can see the sun during the summer or during the solstice, like aligned with some of the mountains. This is in the center. In here is more difficult to get good night skies, as you have Santiago, that is huge. You know, almost the half of Chilean population lives in Santiago. So it's a pretty great hub of light pollution. But if you go to the mountains, like, I don't know, maybe 1 hour driving, you can get into the mountains and lose this light pollution and get some of the best night skies. In here is Bartle 3. It's in Cajón del Maipo. That's the name of that place. This is also near that place with some of the people that really wants to learn about the night sky, some of my students. And well, we also have the snow, you know, less than 1 hour driving, you get to the mountains in the middle of the snow, and 1 hour driving the other way to the west, you have the ocean. So everything is so near.
You have everything.
Exactly. In one day, you can go to the top of the mountain to see the sun rising, and during the afternoon, you can see the sunset during the same day.
Wonderful. Wonderful.
So this is the place I told you that there are people with mining projects that are gonna, I don't know how to say it, but this night sky have a deadline because of these projects, because they want to put all the companies in there, the light pollution will increase a lot. And this place is amazing. Actually, it's so similar to Iceland. This is another volcano. This is El Planchón volcano. And actually, because of the weight of my equipment, I try to not make like a lot of trekking because they're too heavy and I'm very small. So I try to don't make too much trekking. But in this place, you can get there by car, and it's Portal 1 now. Portal 1, yeah, night sky. The airgo was almost visible at the naked eye. You can see like the different tones in the sky. And well, you have all the southern part in there with Magellanic clouds, Carina nebula. And it's the southern part of Chile. This is the last one that I wanted to show you with the Villarrica volcano. You have so many volcanoes that actually there are places where you can align them. For example, this place is, you have the volcano aligned with the southern celestial pole. So it's like, yeah, exactly, to be able to find those places and those alignments is very mind-blowing. And well, this is the most active volcano in Chile. And this kind of sites where you can watch the night sky is just really mind-blowing. And you can reach them, I don't know, maybe walking 20 minutes, less than 20 minutes. These are, this is Volcano Tolhuaca, Volcano Loquimay, and this way is Volcano Jaima. Well, you have in here, you can see in this 360 degrees, you can see around 5 volcanoes. And you can be in the very middle of them. Well, that's some of the things I wanted to tell you about the Chilean night skies. And
so Karina, let me make sure I have your website that I can share with them. There's obviously some people that now want to get to Chile as soon as possible.
Yep, and I'm one of them. But I promised Maxi,
we'll be waiting
first, then Chile. I have to go to Argentina first, so it will be higher on the list than New Zealand. I think
we're so close. We're so close with Argentina. We can make Argentina and Chile.
Make it the same trip. Maybe that's how we will do it.
Wonderful. Wonderful. Well, thank you, Karina.
Excellent presentation, Cari.
Yeah.
Thanks.
It's
going beautiful presentation.
And thanks a lot.
My serious comment is that I love the fact that you've taken the night sky. It's not just about the pretty pictures or the processing. With the type of sky you've got, you really don't need to do a whole lot because the Milky Way is that bright. You just have to capture it, and you're capturing it out of the love of the night sky to present that and say, this is how beautiful our landscape is when you add the night sky to it, and that the focus is on that. That's been my focus for imaging as well, and I really appreciate seeing just how far you're taking it, just how far it can be taken as far as outreach goes. So that's it's wonderful to see that, and hopefully, it's as self-sustaining as it needs to be, to where you're able to do it for quite a long time.
Thanks a lot. Well, we're encouraging more people to do this, because the more we are, the more people when we can convince to protect the night sky and to enjoy them and to connect with them, and to make this perspective effect, to make this change, this mind change, right? Just because of watching the night sky. Actually, the very last thing I wanted to share with you, if you want to make like the virtual tour, in my website, you can see many.
Oh yeah, you were telling me about these 360-degree panoramas. Very
So
cool.
if you're not able to travel yet, you can just visit them by this 360 panoramas. Well, and thanks a lot.
Thank you so much.
Thank you.
Thanks to you guys.
Okay, so up next, we will go from Chile to Brazil to Marcelo Souza, who just finished up his I forget which year it is. I think the 14th annual aeronautical and astronomical event, and so that was it was nice to be part of that. And Marcella, I want to turn it over to you.
Hi, thank you, Scott, for the invitation. Nice to be with all of you. Chile has a wonderful sky. I was there and I visited the VLT and São Pedro de Atacama. The sky is very beautiful. But here in Brazil, we also have a beautiful sky.
Yes, you do.
I will show here because this Friday, last Friday, we have a celebration here because we have the first dark sky park of Latin America here near us, or near where I live here in Brazil. And I will share the screen on a moment. That's nice. Okay. First, I don't know if someone talked about this. Because on May 12, it's announced that you have a groundbreaking Milky Way result from the Event Horizon Telescope. What everybody's talking about is that probably they will show the first image of Sagittarius A, the supermassive black hole at the center of our galaxy. They already was responsible for the first image of a supermassive black hole, that is this image here. And I think that what is being shared is that probably they will show an image of the black hole at the center of our galaxy on May 12th. I don't know if someone knows more about this announcement, but is what they are saying. It will be fantastic, this.
Yeah, everybody's on pins and needles, as we would say in the United States, about this. So if you're into astronomy and understood what the Event Horizon Telescope group did, it's mind-shattering to think that they were able to actually image a black hole, and we think they're about to do it again. So
yes, this will be fantastic if they announce what they are imagining, right? And the sun, only to show, because the sun is very active. I have another X-class solar flare, and probably we will have another one very near. Then this is the message I received today from Space Weather. Get ready for more flares, because a new potentially very active sunspot group emerged today. And the sun is very active. It is time to look to the sun and to take care, because if you have a strong activity in the sun, probably you have another event like the Carrington. This is what I'm concerned about. Let's see what will happen in this period. And we are preparing for the eclipse. For us, it's very important because the next one for us here will be only in 2025. Then this is important for us. Here, now we have the opportunity to see all the eclipse, the solar eclipse, the lunar eclipse, sorry. And for us, this is time here in Brazil. For us, it will be during the night. It will begin before 11 and 30 p.m. Then we will be during all the night here in the streets with telescopes. See if we have people to see the eclipse with us. This is our next year. We have here in Brazil annular solar eclipse that you can see also in United States in 2023. But near us here in Brazil will be a partial solar eclipse on. And this is the path of the eclipse. Is annular solar eclipse. And here in our city, here is the north region of Brazil. They are organizing many activities here, in this, mainly near the ocean here. They are organizing many kinds of activities for the eclipse. In our city, we will see like this. It's a partial eclipse, almost 42% coverage of the sun. You see. And the next one for us will be only in March of 2025. The total lunar total eclipse. This is the reason that we hope that we have clear skies, because it will be an opportunity for many people here in our city. This is the next one, 2000. This is for time and data simulation of the next eclipse. And this is what I prepare. And this is the activity that we want to organize during the eclipse, that is to measure the distance between the Earth and the Moon at the moment of the eclipse, using only trigonometry to do this. You have only the triangles here, and then we can make use the only geometry we can, and the proportion of the two triangles, we can measure the distance between the Moon and the Earth. Now I have since I believe that you have 2 weeks that we organize events with one day after day after day. The first one was the international meeting of astronomy, the 4th, that Scott participates. Thank you, Scott, to participate in our events. Here are images of the event in the theater of our seats. This is our group. We have here many students that participate in our groups, and most of them participate in the project that we have the support of the consulate of the United States in Rio de Janeiro. They're developing here some of the online presentations. And here is something that's curious, because we have a TV program in our city. I don't know what I did here.
Uh-oh. Alien abduction.
Sound. This is a guy from here that produced a program about our events. Here is part of what happened here. Yeah, the invited speakers that was here in our city that participates here. We have also, this is the Dark Sky Park near us, the first Dark Sky Park of Latin America. Our students talking about astronomy. And this student, she has an asteroid with her name. He's the famous astrophotographer here in Brazil. This guy is a student with 17 years old that he already solved the Einstein's equations, and he's working with Dirac's equations. He's in the last year of high school here.
Wow, very smart.
We're talking about asteroids because we are working with asteroids now. No? And the Bruna Pontes, the girl that I said earlier, she has an asteroid with her name. That's Bruna Pontes, the name of the asteroids. He is the representative of the Consulate of United States here in Rio de Janeiro. The guys, the students that work with animations, producing animations for TV.
Mike Simmons.
He's Dr. Varujan from NASA. Sorry.
Bless you.
Dr. David Levy. That's
great.
These are the guys that participate in the first day, Friday at night. Sorry because I can't. And at the end, I have Nicolina here.
Great.
I'm trying to move here on a moment because something is not working. What I did here, that it's not working, Scott. On a moment. I'll return with the presentation. Let me move the... Okay. And we had another drive-in during this week. The same week we organized the international meeting. We organized the drive-in of another event, 2 days of sky. He had characters, and we have cars there. People are having cars, and they see our presentation there. And we have a big screen to talk about astronomy and the participation of the characters here. This is your telescope that you donate to us.
Okay.
We use it today yeah, in the event. Here is our team that participate in this presentation. And is the biggest shopping center of our city. Here is the first international dark sky park in Latin America. It's located near us here in a forest, in a big forest that we have near us. And we have the inauguration of the dark sky park this last Friday. Here is the park, and recognizing that is, and here is the event that we had there. It's a small city, Santa Maria Madera. The city has only 10,000 people that live there. It's a very small city, and they are celebrating this. We are doing a new activity there that is a planetarium in an open space. We use a green laser to show the constellations there. And here we were seeing the South region with the Southern Cross, Carina, and the big Magellan cloud that we could see. And also we saw the False Cross and the Geobox, Omega Centauri. It's a fantastic place. Yeah. And they have an orchestra. I don't know hear the sound, but I can say they are playing the Star Wars music.
What a celebration.
Yes.
That is wonderful.
You see the lights here, all the lights. This is only the headquarters of the Dark Sky Park that's located 20 kilometers far from the park. Inside the park, they don't have artificial lights. They don't have power. And the park is so big that it has parts of the park in 3 cities, different cities. Here's everybody's looking for the Southern Cross. Here I was showing using the green laser. I have presentations here and here. And also we organize events after the celebration for the Young Star of Tomorrow in schools near us. We already visited 31 schools. We are near. I think that at the end of May, we'll be in 40 schools, different schools. Here are the students that participate in these events. Here they are looking to the sun with the glasses, special
It's a tremendous program. It's wonderful.
And one of the students today, she received a congratulations in the council's, I don't know how to say in English, but the city council house, is this that to say? Where you have the people that make the laws for the city. Then they give, they send congratulations to these students here for her participation in the project. He is responsible to produce apps for smartphones. She's very young and she already knows how to make apps, and she's doing apps for astronomy, like variable stars, now about the space exploration, about all the rockets that we have in the world. So this is our activity here. Thank you very much, Scott.
Wow, wonderful. Wonderful. Congratulations on your successful events and your continued inspiration in all the education you're doing in astronomy with your team. Marcelo, it's wonderful. It's wonderful. I'll remind the audience too that Marcelo is the senior editor of Skies Up magazine. It's a global astronomy magazine. You can get it by going to explorescientific.com/Skies Up. I'll put that in the chat here for you to go and get your free downloads. But right now, I'd like to introduce Norm Hughes. Norm is often on our chats. I believe this is your first time on Global Star Party. Is that right, Norm?
Yes.
Okay. All right. So let's go ahead and bring you on, and we're really happy to have you be part of this. Let me.
Welcome to the big time, Norm.
Thank you, Adrian.
This is it.
Yeah, let's bring on the real amateur now.
Here we go. I love real amateurs, so it's wonderful because amateur astronomers. Well, the name implies that you love astronomy. You know, amateur
Exactly.
love, and so certainly we know that you do. And
I do. Yeah. Probably 90% of these global star parties, I've only missed them because of work. So
yeah,
this is pretty awesome stuff. I'm honored to be here. So
yeah, we're honored to have you. So
see if I can get a screen share
going.
Turn it
over to you. But before I do, tell the audience a little bit. Now I know that you're in the chat all the time, and people are always telling you hello and howdy and all of that. But and I see you joking with your friends also in the chats, and I love chatting there with you as well. But tell us more about how did you get started in astronomy? I mean, what brought you to all of
long
this?
story short, I went to Carlsbad, New Mexico in 2011. Never looked through a telescope in my life, mid-50s or early 50s. My boss was in charge of the dark sky program there. And his name was Chuck Burton. I don't know if you have ever heard of him. His name's Charles Burton. He's pretty known in the telescope industry. And he had a beautiful picture of Orion on his wall. And I started questioning about it. And that's when I learned he was doing the star party. So he invited me to the next star party to come just hang out with him.
Okay.
So I walked up and he had like a 30-inch Dobsonian. I looked at, what do you think I looked at? Saturn. And it just blew my mind.
Oh, yeah.
And so shortly thereafter, he, let me go ahead and share my screen and I'll show you a picture. Okay. Shortly thereafter, he, okay, you see my screen?
Not yet. This takes a little bit of practice. You have to go and press that.
This is your rookie hazing initiation, Norm.
Yes, that's right. And then you select which you're going to see all your thing, you select it, and then you commit to it.
All right, I got them all. I got it selected. You see my desktop of the moon?
Not yet.
No,
wow.
I think there's a button you have to basically go share screen. There's like one more button to hit.
Yeah,
and then it'll actually do.
There
There
you go.
There you go. I thought I hit that. I
And
hit
now
it,
we
but
got
it
the-
didn't
There
want to
you go.
work. So, all right. So let me. So anyway, the park had a telescope that nobody was using, and he said, "Why don't you sign it out, learn how to use it?" And sorry, the picture's small, but I downloaded this off of my Facebook page. So here I am. This is an Atlas EQG with an 11-inch Orion. My first time. I didn't even know what an alt-az was. And so I'm reading the manual. So my wife snuck out and took this picture. So this was my start in astrophotography. So he didn't give me the hand controller. He said, you're going to learn the sky by push to. And so for the next 2 years, I used this telescope every night at my house that I could and at star parties and learned the night sky. And then I stepped off and bought my own telescope and kind of spiraled downhill from there. So, I bought an LX90, which was a great scope. Did a lot of moon and sun and super short. Dabble with Orion and stuff, really bright. And then I got the bug. I found a website, which I'll show you here in a minute, that got me into astrophotography. And I dabbled in it for about 3 years, and then for the past probably 3.5 years, and then about 6 months ago, I thought, well, I'm gonna get serious at it. I played. I mean, I didn't have my perfect polar alignment. I just took pictures and stacked them, and they a little fuzzy here and there and had problems, but I was proud of them, you know. So I decided 6 months ago that I would get super serious. So I tore the telescope apart, fixed it, did everything to it, greased it, all that kind of stuff, tightened up worm gears, balanced and double balanced and polar aligned, and got my gear all set up. And this is my setup now. So it's a full blown run from the house. It's totally automated. And so it's
look at that.
12-inch Meade, 81 millimeter Williams optics, and then my little 60 millimeter guide scope. That's a 294, a 290, and the Canon EOS RA.
Man.
And so I switch these cameras back and forth, and this is mono, and of course this is color. So this is my setup now. So that's I'm fixing to build me a little observatory probably as soon as these spring storms break. So get it built on top of it. Right now I just put the 360 cover on it. So
sure.
So yeah, just a couple of quick pictures that I've taken. Now I don't want to get off onto some programs for you guys. This is all narrow, most of it's narrowband stuff. Of course, this is Pac-Man, and this is a color image, and then this is my Orion I just finished. I wanted to try to capture the dust, and so I set off. This is 276 images. Ranges anywhere from 2 seconds all the way up to 600 seconds. And I wanted to capture this dust here. And I think I did a fairly decent job at it. This thing's loaded with flaws. The data didn't want to play nice together. It took me forever. Right now with this image, I want to give a shout out to Sean at Visible Dark. If you guys aren't using his tutorials, you should, because I probably had 20 tutorials I watched to get to this point.
Wow.
And if I could, if I had the minute, I would show you. I would show you where we started with my Orion, and to get to this image. But most of it was done with Sean's tutorials. So he has some amazing stuff. So that was my Orion. I was really glad I got all this dust back here. So, and there's a little waterfall. You have the waterfall in Orion. There's the waterfall right there. It's a little HA object.
Oh yeah, check that out.
Yeah, it's there. Well, it's called the waterfall. It has a name. I don't know what it is, but I mean a designation. So, then I just, when I started, like I said, getting serious at it. This is my M51. This was my first ever Galaxy to ever shoot, and of course I got a lot to learn. I'm still new at all this processing stuff. My Rosette Nebula. And then this one I was glad to have. I was after this. I mean, this is M46. Everybody knows what M46 is, a beautiful cluster with a ring nebula out in front of it. But what I was after was this little guy right here. You see him right there, that little guy. That's PK 231 plus 4.1. There is no information about it on the internet to know how far away it is, whatever. There's nothing about it, but that's what I was after. I saw it in another guy's image, and this whole thing is just LRGB 20 minutes on each filter. And this was all processed with one of Sean's start to finish tutorials, and it turned out pretty sharp. So, and then this is one I didn't get to finish, my witch head. So I needed more data to fix this up here, but this is a tough object to get. So, but that's just some of my images. Like I said, I've just started getting really serious at it.
Yeah.
What I do want to real quick is run through a couple of programs that I use. I mentioned this in Astro TV's chat one night, and nobody had ever heard of it. And this is a program called Astro Toaster. This is a great program. It's free. If you're like me, I use the SkyX to control everything: my telescope, camera, filter wheel, auto guider, everything. And I don't use Sharp Cap or anything like that. This thing, as much as this thing costs, it has a terrible fits viewer when it brings up your images. So you can see that's what the images look like in a program as expensive as Pixelsight. So they're pretty terrible. So for a lot of years, I've been using the Astro Toaster. And when you set you can use it on with any program. When you say your output file, then when you set up Toaster and you go to settings, you just pick your input. So you're going to grab that folder where your other program's putting your images into, and it'll just pull them in. As it dumps one in, Astro Toaster will pull it in and stack it. It's live stacking on the go. It's a great way to see what your data looks like, before you get into the heavy, processing that we do with the images. This is quick, down, dirty. You can make all kinds of adjustments on it. You load it up, you hit monitor, stack, and refresh, and it'll just keep bringing the images in as you're downloading them off your camera. So it is dependent on Deep Sky Stacker. So you have to have Deep Sky Stacker. That's how it runs its algorithms through Deep Sky Stacker. So you have your Deep Sky Stacker folder right here. You just have to pick Deep Sky Stacker in x86. And other than that, it's a very simple program to use. It'll stack them. When you get fresh, the new image, see, there's my light pollution with all my LED lights. So that's the power of this program. We just hit auto expand, and it does an algorithm to determine what's the best settings for the image. And it takes a second. These are big files, so it kind of struggles. And then it does that, and then you just start playing with your adjustments and tone it all down however you like. And there's all kinds of contrast, but it's a great program. It's free, and it's great for on the fly. So it's at astrotoaster.com if anybody wants it. Like I said, it's free. He just released a new version. It's got
spelled like toaster, like TOASTER.
TOASTER. Yes, sir.
Okay.
You can do different stacking modes. You pick your here you're going to pick whatever file you're using, to do it, and then you can go into stacking mode. It could be used for narrowband images. You can go in all kinds of stacking modes. You can assign your channels, and it just works. It's a great little program, and it's like I said, it's awesome. I use it every time I image because I just watch my images as they come in to see what the data looks like. Pretty nice program, and it's free. So the last thing I want to do, I'm not going to take up a bunch of time, is I want to introduce you guys to a website. Let me pull this up over here. I've been a member of this website since 2011. It's called Night Skies Network. It's owned by a friend of mine named Joseph Sardina out in New Jersey. We're really good friends. This is where we live broadcast all the time. I'm surprised somebody's not live broadcasting tonight. There's many people that have channels on here, and we just do live broadcasting, and you come in and everybody chats and everybody can talk, and it works on any platform, phones, it doesn't matter. You don't have to be a member to come in. You can just go to newNightSkiesNetwork.com, and there'll be a blue button here. It's what's called big blue button.
New Night Skies.
New.nightskiesnetwork.com. Okay. And there'll be a blue button here. You just click on the blue button and you'll go into their page, and the chat's all over there. I wish somebody was here, but right up in the corner, there's 3 dots, and you hit that and say leave meeting, and say okay, and then you can type your name in and rejoin the meeting, and then your name will be in chat. So you don't have to be a member to come in and visit.
I see.
But it's free. You can sign up if you feel like you ever want to try to dabble off into live broadcasting. There's a lot of us that do it.
That's cool.
From all over the world, with people from Australia, New Zealand, England, Canada, all over the United States that come in here in live broadcast. Some nights you'll see 3 or 4. You see people during the day from like Australia and stuff, and a lot of sun and stuff like that. So I just wanted to kind of introduce people to this and give you something else to put in your things to play with and come in and visit sometime at Night Skies Network. So it's a great little program. But that's about all I have, Scott. I just wanted to come in and enjoy the program. And
we're really happy that you joined us, Norm.
I got to find out.
Those are great images and proof that once you get off into this hobby, you tend to you just go with it. It takes over, and you start like everyone starts with an image, and the images then they begin to show more and more detail as you keep going. And after a while,
when I started my journey, my images were obviously terrible. I lived in a Bortle 8 sky, and but I posted my images anyway because I want people to know that you don't just automatically make pretty images.
Right.
It's a long road to get there.
It's a lot of work.
It is.
It's a lot of
long
work.
road to get
It's
there.
Also,
like I said,
it's also too, I think we all develop an idea of what we do it for. Yep. And as soon as you get that, then your images start to take shape. You are after something specific with your Orion image. You've got plenty of images with the Orion Nebula and the Running Man, but you were after something specific. So when you worked at it, you ended up, once you got the results, you could sit back and go, wow, I may have gotten more than I thought I was going to get.
Yeah, exactly. I did. But yeah, you're right. I mean, I got tons of friends that have never looked through a telescope, and they love to see my pictures on my Facebook page and stuff.
That's
why I do
they
it.
keep you going. I mean,
exactly.
After a while, they become to expect that you're going to post something.
Yeah.
And then
I get asked all the time, how come you haven't posted anything in 3 or 4 months? So, well, it's raining,
Yeah, it's been raining for 3 or 4 months.
Yeah, this is our tornado season. So
that's part of the reality check I want to. Some of the images that I've been picking as I've been watching the presentations, I decided, you know what, maybe we'll share a little bit of a reality check, why it can be so hard to get the images unless you go to a beautiful place. Like Cari basically had me wanting to retire right now and just pack up and move to Chile. I'd love being under something like that I've only gotten a taste of dark skies from Okie-Tex. And I don't know, Norm, if you've had a chance to go to Bortle 1 and look at stuff.
Yeah, I lived in New Mexico. Was Bortle 2.
Okay.
For 3 years.
Yeah. You saw a dark sky for days on end. So
I've seen so many stars you couldn't make out the Big Dipper,
Yeah.
So but my friend Joseph Sardina that owns that site, and another one of my friends, and Scott, you've had Francis Walsh on once showing you I think he showed you the observatory down in Texas that my two friends have. We have a lot of gatherings down there. It's a Bortle 2 sky, so that's where we're going for the solar eclipse, right down there in Texas, in Hill Country.
That's right. Yeah.
Yes, I challenge you all. You're going to be at a Bortle 2 sky, because I don't know that I'll be able to do it, but someone might. The lunar. Well, the moon is going to be around Antares, I believe, when it's blood red. And as you can see from the image I've got, the galactic core is going to be underneath that.
Yep.
Until I realized that I had signed up to bowl that weekend, I knew exactly what shot I was going to go for. I was going to go somewhere dark, hope it wasn't going to be cloudy, and this was going to be epic. And then I realized I had to bowl, and I said, no, I'm going to be in Vegas. So I hope somebody gets the image I'm looking that I would love to get. And, we're going to make sure that this never happens again, where a nice astronomical event gets blocked by anything else in life. it hurts me to know that I have to. I'm going to be following it online, but I'd rather be out there doing it. I mean, I may sneak out of the bowling center and try and steal a shot before running back in. You know, we'll see what happens. You know, maybe fate will be on my side. I don't know, but that's going to be a really cool day. A lot of people will be looking up on that day, and I'll be encouraging bowlers to look up. Forget about your scores and just go look outside at that eclipse. And maybe if I can't see it, maybe I can get a lot of other people to appreciate seeing it. And I hope that works out. So
Scott, thanks for the time.
Great images, Norm.
Yes.
Thank you.
Yes. If you get a chance, Norman, if you for some reason didn't get the URL correct for the Night Skies website, but if you could either post it here in chat or
I'll put it in chat.
Okay. Great.
And then appreciate you letting me have some time, and I hope to do it again. I want to do some. Now we get into summertime, maybe some of the star parties have for live use for you to fill in.
It'd be awesome.
That would be awesome.
That's what I'm working for. So
yep.
But I appreciate the time, and everybody. Everybody's been great tonight. Appreciate it. Thanks, Scott.
Thank you. Thanks for being a big part of it.
Thank you.
Bye-bye. Okay. All right. So, gosh, Adrian, what did you think? I know that you were really impressed with the night skies down there in Chile. So
yeah.
But you are no slouch yourself. You make beautiful deep sky images of our Milky Way, and I'm always impressed to see what you have. Because you're a great photographer, and it shows every time.
I appreciate that, and actually, that's the way that I'm going to do my presentation, Scott, is to show what does a nightscape photographer do when his area is just too cloudy. So this will be a journey of what I shoot when there's nothing to shoot, and what you do when there is something to shoot. So let's start with let's see, we'll start with one of the books that I'm writing and trying to do is this place on a rare clear night in my state is Point O'Bark Lighthouse Park, and I am interested in making this a dark sky preserve. I'm trying to get in contact with the folks that work with this, that take care of this lighthouse. It's a true Bortle 3 sky out here, and it would be nice if headway could be made. Things like the light that they had here that night, if that's turned off, if they're able to turn off some of the other lights on designated nights where it would be stargazing, this place would be perfect for that. So this is one of the bold goals that I have, is to make this, and you can see kind of Milky Way here, is with the exception of the lighthouse. We'd let the lighthouse do its thing because that's, it's an important function. But if the rest of the lights could go off for a specified amount of time, this would be a beautiful place to image. However, the reality in Michigan is this. Clouds. So here I am. I thought I was going to get a pretty good night, and then clouds drift in. A couple of the places that I go in Michigan, I think it's going to be a good night, and clouds drift in. So I just take pictures of the clouds. Sometimes I get fortunate and the clouds recede. And when they do, I'm looking for a couple of images in particular. Well, here we have a lot of clouds. So you've got there's that same area, and you've got that, the kind of a cloud / seashore mix. So you try stacking your images, and I'll see if I have the stack. Not seeing it. It may be this one. Well, this is one of the images that I took. There was a stack, but I'm not sure I brought it in the folder, and I won't worry about it. I'll give you all a story behind this image. We'll stop here on this one, where you've got some cloud cover and you've got the Milky Way rising.
Yeah, look at that. We lost your audio, Adrian.
Okay, can you hear my audio now?
Got it now. Yes.
Yeah. The mute is in front of it, and if I touched it, it mutes me.
I know how it goes.
Yeah, that'll be useful for you later, Scott. But right now, the story is so it's a heartwarming story because this was one of those ways of using night photography. The gentleman who passed away on January 3rd. I worked on processing the donation that he gave to our astronomy club. And so in looking at a death certificate, I looked for the time he was pronounced dead. It gets morbid, but it gets heartwarming. 8:25 a.m. on January 3rd. I looked at my Sky Safari Pro. I looked at Sky Safari Pro, put it in on January 3rd, 8:25 a.m. And to my surprise, this was the sky that was up at that time, but the sun was right on the horizon. We're around the area where in my picture, I've got a glow from a distant Canadian town here.
Mm-hmm.
That's where the sun was. And the summer triangle was in the same position. So this photo, I told that to his brother. I said, this photo shows you what the sky looked like, except in January, the sun had broken the horizon and M15 had broken the horizon over here. We want to pick out a star for him. We thought about maybe one of the stars of Delphinus, this top star here. It has a name, but we wanted to designate it in honor of his brother. And what I told him, I would print this out for him and mail it to him. And he could put this picture, the picture of the sky at the time of his death, with his ashes and as a memorial. So this image is destined, this summer triangle rising is destined to be a memorial picture for a gentleman who passed when the sky looked like this on January 3rd. So to me, our night sky images can mean more than just a picture, and even the type of outreach that we do may go beyond just pointing at the North American Nebula or Delphinus the dolphin or the coat hanger and saying, look at that. It may have even deeper significance to someone out there. So, that there's a lot more that these images can do. And this image, taking the image, I may not have thought of that, but then going back and referencing it, it takes on even more meaning. So that's, I think the importance of showing the night sky can go beyond these sort of things. This is a similar type of image. It's a small version, so I'll zoom in. So the quality may not be as good, but this is a view. The church that was over here, St. Paul on the Lake, I gave them this image because they may be able to use it. This is the view from their church.
Wow.
And this was the moon rising over a lake that their church is situated on. And so I shared it freely with that church, and that was basically what I did to share the work that I'm doing. So now you're seeing there's a lot of other images here, and we're going to use those to tell the story. I know shadows was a part of the story that we tell, and here we have shadows on the moon. There's a difference that capturing this quarter moon and the next quarter moon I'm going to show can make just by the location of the shadows. There's lunar X and lunar V. This is a quarter moon, a first quarter moon captured when the shadows sat in this location, revealing these features on the moon that this makes it look like an X and it looks like a V. And they're mountains and ridges. These are craters that border this region. And because of where the shadow is, it creates this little illusion for us. And it's one of, when taking pictures of the moon, it's one of the illusions that I've tried to catch numerous times. And this was one where I was successful at catching it. This one, and maybe this may have been 30 minutes later, I was unsuccessful. There's the lunar X, but you see the difference. It's harder to see. You recognize it, the shadow's over here. But what you recognize is that you've got this region and you've got the 3 craters that border that side. And then the lunar V is here, but it just looks like a part of the terrain. So when you take your photo can be important. Shadows can play a big role in the areas of the moon that you try to look at. But of course, where we are, it can be cloudy. So this is what it looks like to the naked eye sometimes when you go out and you can't see anything in the sky. You take an image and your image looks like this. There's no clouds at all in the sky. And this is what we're faced with a lot. So there's my bowling ball that I'm taking with me to Vegas. And that was it. That was all that I took a picture of. So what do? Well, you do a few things. You go out in nature. You go out and shoot at nature. So then you share the cardinal. You look at the baby owls. And you, let's see, those are the only 2. You go to baseball games where one of your stars in Detroit, that's one of his 3,000 hits. That was hit number 2,998. And your favorite team, your captain of your favorite team breaks a bat, but the team wins that night. So you take your equipment and you go out and you shoot that. Then when you have the opportunity, you shoot images like this, where now you're aiming at people. This is little Luna, who was a part of a the Rainbow Connection. It was a charity event where a lot of donations were made. And that was the very last picture. This was the very last picture I took. After we got this cute photo, we just said, okay, we've got enough. So we stopped there. Then we take this is my daughter, whom I took out to dinner before coming on. And nice. She's all grown up and 16. So we have to point our cameras at other things when our skies look like this, where you can barely see any stars. So you end up learning how to do photography. Here's a nice landscape for you, Scott. Couple geese flying in this area here. So this is regular landscape photography. But then if you go to a Bortle 1 site,
I mean, it's still all part of the universe.
Yes, it is. So we call it landscape astrophotography because you've got a landscape like this. It's photography, but then you can go out here and now you have astrophotography. And this is the sky glow that you saw in Chile and some of the red colored sky glow. This is, of course, Okie-Tex. I have a choice between coming back here or going to Chile. I would take the option to go to Chile. I still have to figure something out there. But
Okie-Tex will be cheaper.
Yeah, it will. But I will tell you, this is just beautiful to see. A couple of the pictures that I took out there last time were pictures that accented the colors but represented what you see with your naked eye. And there was one of the zodiacal light with the moon in it. I didn't find it in time, but it's okay. And I think I've shown it before. And then the panorama, I think this was, same camera. The skies are absolutely beautiful. And right now, here's the Pleiades over here. Mercury and the moon will be close by. Glenn Roberts, who I think was on earlier, this would be something great to go out and try and photograph if you can at sunset. It makes for, these things make for a beautiful photo. And the panorama, this was the group I was with, University Lowbrow Astronomers. And I even got stars. This was interesting. I have stars in the reflection on this truck. That's neat. Look at that.
Oh, yeah.
Very interesting. Yeah. Oh, and there's a beehive right above it. So you never know what you're going to get when you take photos. Now, of course, if you go out and you get your modified, well, actually, before I show the modified camera view, this is with a non-modified camera, if I am not mistaken. This is not a modified camera, and this is how much data you get in a Bortle 1 sky. The hydrogen alpha regions do show up. Maybe not as well as with a modified camera. All of these streaks are very likely planes, satellites, maybe a meteor. Lots of streaks in the sky on this was a single 30-second exposure. And then you bring in your modified camera and you get all this data in 30 seconds. And you even get things that you normally don't see at my normal latitude, like the cat's paw and the lobster. My goal is to try and go somewhere where I can get even deeper and see if I can get a little more. I have to be careful where I venture out, though. They're at night when I go to Okie-Tex. And of course, this image for readers of Skies Up magazine is the original image that you later saw. And what I like about this image is the fact that you saw the other Milky Way. A lot of Milky Way photography is done with the galactic center, but especially at a dark site, you have the opportunity to take other regions of the Milky Way and make them just as prominent. With Orion over here, maybe this is the witch head, a little bit of it, maybe it isn't, or maybe it's this area right here, just around, next to this. It could be this area here. But the whole point being, there's nebulosity here that you can capture because the skies are so dark, and you can focus on different regions of the Milky Way, and you don't necessarily have to shoot the same places that we all shoot, when we're aiming to get beautiful skies. So when it's cloudy and you have nothing better to do, continue to take photos and hone your craft, because you never know when you get to a clear sky like this, you want to be ready to take advantage of it. And if all else fails, if we've learned nothing else, we just need to move to Chile or to Argentina with Maxi and just get better skies, and then life is that much better. So that is my winding presentation, what I've been doing over the last couple of months and what I'm looking forward to all the way in September. In the meantime, there are some dark skies to the north in Michigan, and it's my hopes to go back there and take some photos as the Milky Way does continue the galactic core, I like to call it. I don't like to call it the picture behind me is what's going on with the galactic core in the early morning before sunrise, which is when I took that picture behind me. And that was a Bortle 2 zone. And that was a minute-long exposure. And that was the first time I saw that much detail, including the region behind me, a part of the galactic bulge that, I was quite pleased, even though I missed the initial shot I wanted to take. That was 30 minutes away. The sun came up before I could take that one. But I would do it again because this was a wide open field and it was beautiful. just to see. So so with that, I'll turn it over to you, Scott.
All right.
Thank you for always having me on, and even when I have to be late, I'm always happy to come and share my images.
Always welcome. Thank you so much. All right, so we are we're expecting to see Cesar Brolo to come on this particular episode, but he promises to be back on sometime next week. So we are going to finish the 92nd Global Star Party with Maxi Falares down in Argentina, and so we've crisscrossed the world a little bit here, but it's always great to have Maxi on with his amazing images of the southern hemisphere. Maxi, how's it going, man?
Hey, Scott, Adrian, Norman, and hi everyone.
Yeah.
Well, that's we missed the last GSP last week, but you know, we have too much time to do what we do. So basically, well, I was doing last Sunday, the 24th of April, I think it was. Yeah, the Sunday 24th. Let me share my screen. I was trying to do some solar images, and because the sun has too much activity, well, not in this case, it's my background. Let me show you this picture that I did of the sun. You can see the dark spots really clear. Even I was struggled with the wind and the clouds, but sometimes I had some kind of windows that I could take in shots. But also when I realized, and in the moment the sky going very clear, I saw the moon like this.
Oh, I like that.
You know, I
It's
watched.
very cinematic, you know, like something you would see in a movie.
I've often tried to catch the moon like that at times.
That's nice.
It's an awesome way to show the clouds mixing in.
This is another one with a little more exposure, but it's like a smoke, but it's clouds, and of course it was really bright, and this is what the one that I really like, because it's like a fog across the moon. It's very particular picture, and this is only one single image. I did it with my ZWO and the telescope only. I think it was at 0.0001 seconds and 100 gain, I think. So basically that was I doing that Sunday. It was a really good Sunday, but then I had to prepare because the Friday 29th I had to do a presentation for the 28th edition of ProScience. This is a program that organized by Armando Sandanel. He's my teacher of physics, and he invited me to do a presentation for the first time. You know,
Oh, that's cool.
Yeah, and the most cool is that I start in astronomy, I don't know, almost 20 years ago, in the 8th or 9th edition, because I always go or went to the astronomy meetings to do observations. I remember Conrado Kurz showing us the Jewett box cluster, the Omega Centauri, and other southern objects, and it was really cool. And in that moment, also I realized that I wanted to do astronomy. Well, of course, then astrophotography. So, that's the good of this. 20 years ago, I was going to that presentation, and 20 years later, I was presenting to everyone. So this is a part of the group that came. Here's some people that I know, but also here, back here is my dad and my brother.
Nice.
So I was really happy that they want to be there. And here's me doing the presentations. These are kids from a school that came more later, but they are very curious. I don't know if they are excited to go there, because you can see it was really cold that night. But then of this, we did a little observation, but we have too much light pollution. But we tried to do some kind of. I did a presentation like an hour, maybe, explaining a little more of the story of the astrophotography, but also what was in the past, doing the observations, doing drawings, and that was the kind of moment that you can capture something in the history of astronomy.
Yes.
But now you can do it with cameras, Of course, I did with the Hubble telescope. It's a very special camera. The mirror is 2.4 meters of diameter, and that's a huge one that I think nobody can get that, but I want to try to show to the young people, and of course everyone that wants to learn about it, that you can do it with small telescope like this. Here's a Maxwell that I practically started, and well, they liked the presentation, and they give me a little present that says that they thank me to be there, and of course
nice.
I'm really grateful to be part of that. So the next day, the 30th of April, we have here in the south the partial solar eclipse. I went to a rural place that you can see. I didn't know that if I can be there, because it was a really cloudy day. It was really cold also, but and I was really tired. I woke up from a little nap that I took, and when I saw these open skies, I say to my girlfriend, "Do you want to come with me? Okay, let's take some mates and try to see what we get, and also taking pictures." So you can see the cows. When we arrived to this place, we cannot across this farm. No, we can't, but we stay in the entrance. But these cows, it was almost 40 cows here mooing, but then they went off. So I started taking pictures with a Mylar filter that I had, but you can see they're starting to get in some clouds. And I think in this case is, I don't know, the reflection, no, I can see it. It's starting to go in during the eclipse, but then the clouds cover up, and I'll say, okay, that's it. That's all that I get. But well, here's Belen watching the sun. I take this picture surprisingly, but she didn't like it.
Oh.
So I realized that I have a little window very above the horizon, and I say, oh, maybe I can wait. And then I start to see the sun going down, and with this particular shape of the moon. But this wasn't with the filter. This was only with the lens, very carefully taken with the diaphragm, because the light was really bright, even here in the horizon, and taking pictures very fast exposure. And I remember I was running because I want to see if I could go with this between these big trees, and taking with those little trees there. And this is another one. This is practically above the horizon, and you can see
Wow, look at that. That's cool.
That's the old kind of eclipse that I had here in my latitude.
Really cool. Beautiful.
I really love to try to capture it. So I hope. Well, let me share you. This is the satellite image of that day. Let me see if the animation goes okay. For example, I'm here. You can see my cursor of the mouse. I'm here. This is the Buenos Aires province, but I'm here. So there was really cloudy. And you can see the darkness. Let me put it back. Here's the opened window that I had in the clear sky. But look at here more to the south. Let's go back. That here in this place in the ocean is the shadow of the moon. It was minimum, but
oh yeah, but you got it.
In more going up. Oh, sorry. Start to. You can see the edge of the Earth in the day and the night, but here this is the shadow of the moon, partial. Let's see if it goes with the animation, but I don't know. So because in this place it was in daytime in that place, even it was darkness. So well, this is my little presentation. I hope you liked it, and well, I think I will go this weekend to take pictures with small equipment to let's see what I get, maybe to the raw focus place, I think, but I hope the next week to get captured with the total lunar eclipse from here.
Yeah, absolutely. Wonderful. Maxie, thank you.
Thank you.
That was a beautiful image.
Thank you, too.
Good stuff, Maxie.
Excellent image. Yeah, that was a great capture.
Yeah.
Thank you, guys.
The moon with the clouds are pretty spectacular.
Yeah.
I posted on my Flickr account. If you want to see it, I will share it here in the chat, my Flickr page. Here.
Yeah, I'll go fringe it. I have a Flickr page too, so.
Oh, excellent.
You can share your screen if you'd like, Maxi.
Okay. Here.
Oh yeah.
Let's get it.
This is my Flickr page. This what I start to do. I think 1 year ago, almost. Where here's the total solar eclipse in the 2020. This I really
Diamond
love
ring.
to. And of course, well, the moon, some galaxies. Here, the telescope and the moon in the field. This is the reprocessing of that moment. Here's another one. This more like sharpness. And this here is with the flares. I really love this picture. And of course, of the topic of tonight was the lights and the shadows. And this is a really good one example of that.
It's beautiful.
I can imagine now if the eclipse occurs, because we have too much solar activity. So
it's going to be fantastic. Yeah, I hope that in 2024 you can make it to see the total eclipse. So,
yeah, I hope it too. I hope it too.
Wonderful.
Well,
all right, gentlemen. Well, thank you very much. I want to thank all of the people that were on Global Star Party tonight. That would have included David Levy, Carroll Iorg from the Astronomical League, David Eicher from Astronomy Magazine, Bob Fugate. He's actually the father of laser-guided active optics. He was on earlier. Samantha Jewett from the Royal Astronomical Society of Canada. We had Molly Wakeling with AstronoMolly's Universe. Dan Higgins and Peter from Astroworld TV were on. We had Michael Carroll, space artist and science fiction author. Karina Letelier showing us amazing skies in Chile and her incredible astrophotography of the Milky Way down there. Marcelo Souza from Brazil. Norm Hughes, who's right here with us right now. Maxi Filari is also with us, and Adrian Bradley with his beautiful nightscapes or dayscapes as well. So
yeah.
Anyways, it was a great Global Star Party. I really thank all of you for participating, and I want to thank the audience for watching from around the world. And I wish all of you a good night, and I wish that you all keep looking up.
Thanks, Scott.
We'll be back next Tuesday with Global Star Party 93 as we march on to 100. Take care and good night.
Take care, you guys. Good night.
Good night.